There is a place in the middle of North America where 5 enormous lakes sit pressed together like the fingers of a hand. Lakes so vast that early European explorers refused to believe they were lakes at all. They called them inland seas. They drew them incorrectly on maps for over a century because the human mind simply could not process water on that scale, existing this far from any ocean. Lake Superior alone holds 10% of the world's surface fresh water. 10%. Of all the liquid fresh water sitting exposed on the surface of this entire planet, one lake in the Canadian-American interior holds 1/10 of it. If you drained Lake Superior and spread its water evenly across North and South America combined, the entire landmass would be under a foot of water. These are not normal lakes, they never were. And yet, for all their size, for all the centuries of shipping routes and fishing fleets and research vessels that have crossed them, what lies beneath their surfaces remains one of the most poorly understood landscapes on Earth. The floor of Lake Huron alone is less thoroughly mapped than the surface of the Moon. Entire underwater mountain ranges beneath Lake Superior were unknown to science until the 1980s. And in the deepest, coldest, darkest basins of these ancient waters, something waits that nobody has found a satisfying explanation for. Structures, stone arrangements, walls and circles and lines of rock that follow geometries too deliberate, too precise, too eerily consistent to have been placed there by glaciers or currents or any geological process that science currently recognizes. This is not a fringe theory whispered in conspiracy forums. The structures are real. They have been documented by credentialed researchers from major universities. They have been photographed, measured, and peer-reviewed. The argument is not whether they exist. The argument is what they are, who made them, and when. And the answers to those questions, if we ever find them, will rewrite everything we think we know about the deep human past of North America. Not just Canadian history, not just Indigenous prehistory. Everything, the entire timeline. The whole story of when people first arrived on this continent, what they built, how sophisticated they were, and what happened to them. If you're watching this to fall asleep, that's exactly why I make these videos. Maybe subscribe and let me know where are you right now and what time is it. Because what we're going to walk through tonight is not the version of this story you got in any classroom. The classroom version of Great Lakes prehistory is clean and simple. Glaciers receded, people arrived, they hunted, they gathered. Eventually Europeans showed up and wrote things down, and history began. That version is comfortable, it fits on a single page. It requires no difficult questions. But the underwater evidence does not fit on that page. The underwater evidence tears the page apart and asks you to imagine something far older, far stranger, and far more humbling than the story we've been told. We are going to go deep tonight, literally and figuratively. We're going to descend into water so cold and dark that human divers can only survive in it for minutes without specialized equipment. We're going to follow the sonar maps and the side scan imaging and the remotely operated vehicles down to places where sunlight has never penetrated, where the pressure would crush an unprotected human body, where the temperatures hover just above freezing year-round. And on the floors of those ancient lakes, we're going to find things that should not be there, things that raise questions the scientific establishment has not yet answered satisfactorily, things that certain researchers have spent careers trying to understand and other researchers have spent careers trying to ignore. Let's begin with the water itself. Because to understand what might be beneath these lakes, you have to understand what the Great Lakes actually are. They are not permanent features of the North American landscape. They are recent. Geologically speaking, they are almost embarrassingly young. The basins that hold them were carved by glaciers during the last ice age, an immense continental ice sheet that, at its maximum extent around 20,000 years ago, covered virtually all of Canada and pushed deep into what is now the northern United States. Ice 2 miles thick in places. Ice so heavy it depressed the very crust of the earth beneath it, pushing the bedrock down by hundreds of feet under the sheer accumulated weight of frozen water. That depression, called glacial isostatic depression, is still being corrected today. The land around the Great Lakes is still slowly rebounding upward, still recovering from the weight that was lifted from it when the glaciers melted. It rises millimeters every year. It has been rising for 12,000 years, and it has not finished yet. When the glaciers began their final retreat around 14,000 years ago, they did not simply vanish. They melted in pulses, retreating and advancing, leaving behind a landscape that was constantly, violently changing. The meltwater had nowhere to go. The land to the north was still buried under ice. The rivers were blocked, the drainage patterns disrupted, the entire watershed of interior North America thrown into chaos. So the meltwater pooled. It collected in the basins the glaciers had scraped out, and it formed lakes, but not the lakes we know today. The first post-glacial lakes in the Great Lakes region were different. They were in different places, at different elevations, draining in different directions. Lake Agassiz, a glacial lake so enormous it makes modern Lake Superior look modest, covered much of what is now Manitoba, Saskatchewan, and Minnesota. It held more water than all 5 modern Great Lakes combined, and it drained catastrophically multiple times, sending walls of fresh water flooding down river systems toward the oceans and triggering climate disruptions felt across the entire northern hemisphere. The Great Lakes as we know them today, their current shorelines, their current depths, their current connections to each other and to the sea, only stabilized relatively recently. Lake Superior reached approximately its modern level around 5,000 years ago. Lake Michigan and Lake Huron, which are actually a single connected water body despite having different names, reached their modern configuration even more recently than that. What this means, and this is the critical point that makes everything else in this story possible, is that the floors of the Great Lakes were once dry land. Thousands of years ago, human beings could have walked across terrain that is now submerged under dozens or even hundreds of feet of water. They could have built things there. They could have lived there. And when the lakes rose, everything they built would have gone under with the water, preserved in the cold and the dark for thousands of years, waiting for someone with the right technology to find it. The first serious hints that something unusual lay beneath Lake Huron came not from archaeologists, but from fishermen. This is almost always how it goes. The people who spend the most time on and in a body of water, who drag their nets across its floor and feel the resistance of what lies below, who notice when their sonar returns strange signatures from the lake bed. These are the people who first sense that something is different. Fishermen working the Alpena Amberley Ridge, a submerged geological feature that runs diagonally across Lake Huron from Alpena, Michigan to the shores of Ontario, began reporting unusual bottom conditions in the 1980s. Their nets were catching on things. Not the random snags you get from rocky outcrops or sunken logs, but consistent snags, repeating snags, snags that happened in the same locations season after season. The floor was doing something structured, something regular. Nets don't catch the same way twice on random geological debris. They catch consistently on geometric forms. It took until 2007 for researchers from the University of Michigan to conduct a systematic sonar survey of the Alpena Amberley Ridge. What they found stopped them. The ridge, which runs for more than 100 kilometers along what was once a river valley and land corridor between the current American and Canadian shores of Lake Huron, contains what appear to be stone lanes, linear arrangements of boulders running parallel to each other, perpendicular to the old shoreline, forming what researchers carefully described as drive lanes. The kind of structure that hunters building communal kill sites might construct to funnel caribou toward a particular point. The kind of structure that has been found on dry land at dozens of prehistoric hunting sites across the northern part of the continent. Except these are under 40 feet of water. They have been under 40 feet of water for at least 9,000 years, because that is the minimum time since this part of Lake Huron reached approximately its current level. The lead researcher on this project, a geoscientist named John O'Shea from the University of Michigan Museum of Anthropological Archaeology, was not making wild claims when he published his findings. He was cautious, he was methodical, he published in peer-reviewed journals, he acknowledged uncertainty, but he also stated clearly that the linear stone arrangements on the Alpena Amberley Ridge were consistent with hunting structures, that they were inconsistent with any known geological process that could produce such regular, oriented features, and that the most parsimonious explanation was that they were constructed by humans at a time when this ridge was above water, which means they were constructed at least 9,000 years ago. 9,000 years. To put that number in context, the oldest confirmed permanent settlement in Canada, the oldest archaeological site in the country where people demonstrably built lasting structures, is roughly that age. And what O'Shea's team found in Lake Huron would, if confirmed as constructed, be contemporary with the very earliest chapters of permanent human habitation anywhere in the post-glacial landscape of northern North America. But the Alpena Amberley Ridge is only the beginning. Because when researchers started looking at the other lakes with the same systematic attention, with the same sonar technology and the same willingness to report what the data actually showed rather than what the prevailing models predicted, they found more. Not the same things, not identical structures, different things in different lakes at different depths, suggesting different time periods and possibly different cultures and different purposes. The Great Lakes are not a single story, they are an archive, and we have barely begun to read it. Lake Michigan, the only Great Lake located entirely within the United States, had its own surprise waiting. In 2007, the same year O'Shea's team was making headlines with the Lake Huron findings. A marine archaeologist named Mark Holley was conducting sonar surveys of Grand Traverse Bay, a large inlet on the eastern shore of Lake Michigan near the city of Traverse City. Holley was not specifically looking for prehistoric structures. He was conducting a broader survey of underwater archaeological resources, which in most lake surveys means historical shipwrecks, of which Lake Michigan has thousands. What he found instead was on the floor of the bay, under approximately 40 feet of water, a series of stones arranged in a line stretching for roughly a mile, and among those stones, one that stopped him completely. A stone with markings on it. Carved markings. A shape that, when he described it, and later when photographs were circulated among researchers, drew comparisons to a mastodon. A mastodon, an animal that has been extinct in North America for approximately 10,000 years. If the carving on that stone depicts what the researchers believed it depicted, then the stone was carved no later than 10,000 years ago. And if the stone was carved 10,000 years ago, then either it was carved on dry land before the lake rose and carried its arrangement down with it when the waters came, or it was carved underwater, which is not something that the archaeological record of this continent has ever shown evidence for at this time depth. The carving, if genuine, implies a site of extraordinary antiquity, a site that would push the documented presence of symbolic, representational art in the Great Lakes region back to an era when the mammoths and mastodons were still alive. The stone with the possible mastodon carving has been controversial. It has not been definitively confirmed as a deliberate carving by independent specialists. The underwater conditions make close examination difficult. The stone is heavy and fixed to the lake bed. Bringing it to the surface for proper analysis has not been approved by the relevant regulatory authorities, which is itself a complicated situation that we will return to later in this story, because the regulatory and institutional framework around these potential underwater sites is one of the most important and least discussed aspects of why so little progress has been made in understanding them. For now, what matters is that researchers found something in Grand Traverse Bay that was sufficiently anomalous, sufficiently compelling, sufficiently different from anything that could be explained by simple geological processes that it warranted serious attention. That attention has been frustratingly slow in coming. Let's step back from the specific discoveries for a moment and think about the larger picture they suggest. The Great Lakes watershed, the entire drainage basin of these 5 lakes, and the rivers that feed them, covers an area of roughly 300,000 square kilometers. It encompasses parts of 8 American states and 2 Canadian provinces. Ontario alone contributes more shoreline to the Great Lakes than any other political jurisdiction on Earth. And the lake floors within this watershed represent a combined area of roughly 240,000 square kilometers of submerged land, much of which was dry, potentially inhabited, and potentially modified by human beings during the period between roughly 14,000 years ago, when the glaciers began their final retreat, and roughly 5,000 years ago, when the lakes reached approximately their modern levels. That is a 9,000-year window, 9,000 years, during which people were living in and around this landscape, during which the landscape was constantly changing, during which the water was rising and the land the people lived on was being swallowed by the expanding lakes, potentially taking everything those people built down with it into cold storage. 9,000 years is not a trivial span of time. 9,000 years ago, in the Near East, the first permanent towns were being built. Agriculture was being invented. The wheel was being developed. 9,000 years of potential human habitation, construction, and cultural development, compressed and preserved by cold water, sitting on the floors of lakes that have been intensively used by industrial civilization for less than 200 years, and only seriously examined by underwater archaeologists with modern sonar technology for less than 30 years. The proportion of this potential archive that has actually been investigated is vanishingly small. We know almost nothing. We have barely looked. And what little we have looked at has already produced results strange enough to demand much, much more looking. To understand why more has not been done, you need to understand the unique challenges of underwater archaeology in the Great Lakes. These are not tropical waters. They are not the warm, clear, shallow waters of the Caribbean, where recreational divers can see a shipwreck from the surface and descend with standard scuba equipment to examine it. Lake Superior has a mean depth of 147 meters. Its deepest point is 406 meters, almost a quarter mile straight down. The water temperature at depth hovers around 3 to 4 degrees Celsius year-round, and hypothermia sets in quickly even in a wetsuit. Visibility varies enormously. In some parts of the lakes at certain times of year, the water is remarkably clear and divers can see 20 meters or more in any direction. In others, seasonal algae blooms, sediment disturbance, and the simple darkness of depth reduce visibility to almost nothing. The expense of underwater archaeological work in these conditions is extreme. A research season involving a dedicated vessel, sonar equipment, remotely operated vehicles, and a team of trained researchers costs hundreds of thousands of dollars at minimum, and that buys you a few weeks of survey work covering a fraction of the total lakebed area that needs to be examined. Funding for this kind of research is scarce. The academic reward structure does not favor spending years investigating sites that may or may not yield results significant enough to publish in major journals. And the regulatory environment is genuinely complex. The Great Lakes straddle an international border. Different parts of different lakes fall under the jurisdiction of different states, different provinces, different federal agencies, different tribal nations, each with their own rules about archaeological investigation, about who has the right to investigate what, about what happens to any objects that might be recovered, about who speaks for the cultural heritage of peoples who lived in this landscape thousands of years ago. This last point is not a minor bureaucratic inconvenience. It is a fundamental ethical and legal question. The indigenous peoples whose ancestors lived around and on the shores of the Great Lakes for thousands of years have not simply vanished. The Ojibwe, the Potawatomi, the Odawa, the Huron-Wendat, the Haudenosaunee, and many other nations have living descendants who maintain legal, cultural, and spiritual relationships to this land and these waters that predate every government currently claiming jurisdiction over them. When a researcher wants to investigate a potential underwater archaeological site in the Great Lakes, they are not just dealing with permit applications and research budgets. They are dealing with questions about who owns the past, who has the right to interpret it, whose stories about these waters are authoritative, and what happens to discoveries that might challenge or confirm or complicate those stories. These are not easy questions. They are not questions that universities or government agencies have handled well historically, and the communities most affected by the answers have very good reasons to be cautious about who is asking and why. All of this explains, to some degree, why the underwater structures of the Great Lakes have received so little systematic attention, not conspiracy, not suppression. Mostly, just the combined weight of logistical difficulty, funding scarcity, regulatory complexity, and institutional inertia. Science advances fastest where it is cheapest and easiest to advance, and underwater archaeology in deep, cold, fresh water is neither cheap nor easy, but the structures are there, the sonar images are real, the measurements have been published, and the questions they raise do not go away simply because answering them is difficult and expensive and complicated. So let's look more carefully at what has actually been found, one lake at a time, and try to understand what the full picture might suggest. Lake Superior is the deepest, coldest, and most remote of the Great Lakes. It is also the oldest, in the sense that its basin was carved earliest, and its post-glacial history is the most complex. The bedrock beneath Lake Superior is among the oldest exposed rock on the surface of the Earth. The Canadian Shield, the ancient Precambrian craton that underlies much of Ontario and Quebec and extends beneath the lake's northern basin, contains rocks that are 3 billion years old in places. This is a landscape of almost incomprehensible antiquity, and the traces of the people who lived across it before the lake rose to its current level have been proportionally difficult to find and interpret. But there are traces. The shoreline of Lake Superior is dotted with rock art sites, petroglyphs carved into lakeside cliffs and boulders, that researchers generally date to within the last 3,000 years, based on stylistic comparison with other known sites and the occasional association with datable organic materials. The most famous of these, at Agawa Rock on the northeastern shore of Lake Superior Provincial Park in Ontario, includes depictions of what appear to be underwater creatures, serpentine beings associated in Ojibwe tradition with the deep water called Mishipeshu or the Great Lynx. These beings are not mere decorations. They are part of a coherent cosmology in which the deep water of Lake Superior is inhabited by powerful supernatural entities that must be respected and appeased. The offerings made to the lake, the specific protocols for travel on its waters, the prohibitions around certain areas and certain behaviors, all reflect a worldview in which the lake itself is not simply a geographical feature, but a living presence with agency and intention. What is striking, when you examine this cosmological framework alongside the archaeological evidence for underwater structures, is the possibility that some elements of these traditions about what lies beneath the lake might encode actual memory. Oral traditions among the Great Lakes peoples speak of worlds beneath the water. They speak of places where ancestors went during times of catastrophic change and were swallowed by the rising waters. They speak of beings that inhabit the deep places that were once inhabited by people. The scholarly debate over how literally to interpret such traditions has been long and often uncomfortable. Western academic culture has historically been quick to categorize indigenous oral traditions as mythology, as metaphor, as spiritual narrative, rather than as potential repositories of historical memory. But this dismissiveness has been repeatedly challenged by cases where oral traditions turned out to encode real events. Australian Aboriginal oral traditions describing the flooding of coastal landscapes have been verified as accurate accounts of sea level rise that occurred between 7 and 20,000 years ago. Pacific Islander navigation traditions encode real astronomical and oceanographic knowledge that Western science took centuries to independently discover. The assumption that pre-literate peoples cannot accurately transmit factual environmental information across hundreds of generations is simply not supported by the evidence. It is a prejudice, not a conclusion. When Ojibwe elders speak of a time before the Great Water, when the land now beneath Lake Superior was accessible and populated, and the Mishipeshu had not yet claimed it, it is worth asking whether this tradition might preserve some dim, distorted, but real memory of the period when that land was in fact above water, and in fact populated. The specific details would inevitably be transformed by thousands of years of retelling, shaped by the ceremonial and spiritual contexts in which such stories are transmitted, adapted to the conceptual frameworks of successive generations. But the core fact that there was a time when the lake was not where it is now, when land that is now underwater was above the surface, is not mythology, it is geology. And the fact that Ojibwe tradition contains specific, detailed accounts of what that submerged landscape was like might not be coincidence. It might be memory. The search for physical evidence beneath Lake Superior has been hampered by depth more than anything else. The lake's deepest portions are genuinely inaccessible to conventional archaeological methods. The bottom is dark, cold, under enormous pressure, and the sediment that has accumulated over 12,000 years of post-glacial history is thick enough, in many areas, to bury any structures that might exist beneath it. But the shallower areas, the submerged shelves and ridges and river valleys that were above water during the low-stand periods of the lake's history, have been examined in small pieces, and those examinations have produced results that deserve more attention than they have received. Along the eastern shore of the lake, particularly in the areas around Batchewana Bay and Michipicoten in Ontario, researchers conducting broad-scale sonar surveys have identified linear features on the lakebed that do not correspond to known geological structures. These features, some of them extending for hundreds of meters, appear in water depths between 15 and 30 meters, depths that would have been dry land between roughly 9,000 and 6,000 years ago based on lake-level reconstructions. The features are not dramatic. They are not the kind of thing that makes headlines. They are subtle perturbations in the flatness of the lakebed, slight ridges and depressions arranged in patterns that have a geometric quality. But subtle perturbations in the flatness of the lakebed in regular geometric patterns are exactly what you would expect to find if low stone walls or structural arrangements had been built there thousands of years ago and subsequently covered by thousands of years of sedimentation. You would not expect to find perfect preservation. You would expect to find ghosts. These eastern Lake Superior anomalies have not been published in peer-reviewed journals. They exist in grey literature, in survey reports filed with provincial and federal archaeological agencies, in the personal records of researchers who conducted the surveys. This is itself diagnostic of a problem. The gap between what has been observed in the Great Lakes underwater environment and what has been formally published and entered into the scientific record is enormous. Survey work gets done, anomalies get noted, reports get filed, and then nothing happens because there is no funding for follow-up, no institutional mechanism for turning a survey observation into a research program, no clear pathway from noticing something interesting on a sonar display to publishing a paper about what it means. The archive of unexamined observations about the Great Lakes floor is probably as large, in terms of potential significance, as the archive of examined and published findings. Lake Huron, sitting east and south of Superior, connected to it through the narrow turbulent channel of the Staint. Mary's River is where the most formally documented and published research on underwater structures has been concentrated. This is partly because of geography. The Alpina Amberley Ridge, the submerged landform that produced the most compelling evidence to date, is a relatively shallow feature by Great Lakes standards, ranging from roughly 10 to 40 meters of water depth. Shallow enough for human divers to access with proper equipment. Shallow enough for high-resolution sonar to produce detailed images of the bottom. Shallow enough that remotely operated vehicles of modest capability can be deployed effectively. The combination of significant research interest produced by O'Shea's initial discoveries and relatively manageable water depths has made Lake Huron the focus of more systematic underwater archaeological attention than any of the other lakes. And Lake Huron has rewarded that attention with increasingly detailed and increasingly puzzling findings. The Alpina Amberley Ridge, as O'Shea and his colleagues have described it in a series of publications spanning more than a decade, was not a random piece of exposed lakebed when it was above water. It was a specific kind of landscape, a long, narrow peninsula or ridge of land that extended across a wide valley floor, oriented roughly northwest to southeast, positioned between the lower Michigan Peninsula and the Ontario shore. In its geography, during the low stand period, it would have been one of the most strategically important landscape features in the region. Think about what that means for the people who lived there. The ridge was a crossing point, a place where animals moving between different parts of the landscape would be naturally funneled, where different human groups moving in different directions would converge, where the pressure of migration, both human and animal, would be concentrated by the surrounding topography. And on this ridge, at this natural convergence point, someone built stone structures, not randomly, not casually, with intention, with planning, with knowledge of how animals move and how stone can be used to redirect that movement toward a killing ground. The drive lanes that O'Shea's team has documented are not simple. They are not just two rows of boulders with a gap between them. They are complex constructions with multiple components, branching sections, cul-de-sacs, what the researchers describe as hunting blinds, positioned at the ends of the lanes where hunters could have hidden and waited. The largest and most well-preserved of these lane systems covers an area of several hundred square meters and shows clear evidence of having been constructed in stages, with modifications and additions suggesting long-term use and maintenance. This is not the work of a small family group on a single autumn afternoon. This is the kind of infrastructure that a community builds and tends and uses over multiple generations, investing in it because the return on that investment is reliable and significant. These hunters knew this ridge well. They had studied it, planned for it, worked together to build something on it that would feed their community for years or decades. And then the water came and took it all away, and for 9,000 years it sat in the dark, perfectly preserved by the cold, waiting. The preservation is itself remarkable and worth dwelling on for a moment. One of the great ironies of underwater archaeology is that the very conditions that make archaeological work so difficult, the cold, the depth, the darkness, are also conditions that preserve organic and inorganic materials far better than most terrestrial environments. On land, wood rots, bone crumbles, leather disintegrates, plant fibers vanish. The archaeological record of most prehistoric cultures consists almost entirely of the things they made from stone, because stone is what survives. But in cold, fresh water at depth, in the anaerobic conditions that exist on many lake floors, organic materials can survive for thousands of years in conditions approaching perfect preservation. Waterlogged wood can retain its structure for 10,000 years or more. Worked bone can survive in recognizable condition. Even plant materials, seeds, cordage, the delicate stuff that always vanishes from terrestrial sites, can be preserved in the right underwater environment. What this means for the potential archaeological record of the Great Lakes is staggering. If people were living on land that is now underwater, the record of their lives is not just in stone structures. It may include their actual belongings, their tools, their food remains, possibly even their wooden constructions. The Great Lakes, under the right conditions, might be the most perfectly preserved archive of early post-glacial human culture anywhere on Earth. We have barely begun to look. The specific site on the Alpina Ambeli Ridge that has produced the most striking direct evidence of human presence is a location the researchers have designated as the Drop 45 site. At Drop 45, a remotely operated vehicle working at a depth of roughly 30 meters found, alongside the expected stone lane structures, a discrete concentration of animal bone. The bone, when recovered and analyzed, turned out to include the remains of caribou, multiple individual animals. The bones showed cut marks consistent with butchering, with the removal of meat from the carcass using sharp stone tools. The bone was radiocarbon dated and produced ages consistent with the site's expected antiquity, placing human activity there at roughly 9,000 years before present. This is direct physical evidence, not an inference from stone arrangements that might, however unlikely, have been produced by some unusual geological process. Actual cut-marked animal bone in direct association with the stone structures dated to 9,000 years ago. People were there. People killed caribou there. People built the stone lanes to help them kill the caribou and then butchered the animals on the spot. The structures are real and they are human. What is less certain, and what drives the deeper mysteries of this story, is whether the structures on the Alpina Ambeli Ridge represent all that was on this ridge when it was above water. The hunting lanes are the most visible features because they are made of large stones that stick up above the sedimented lake bed and therefore show clearly on sonar imagery. But there may be other features, smaller features built from materials that do not produce the same sonar signature, that are buried beneath the sediment layer and invisible to current survey methods. Settlement sites. Places where people camped and lived during the hunting season. Places where tools were made and fires were lit, and children were born and elders died. Places where things were stored and rituals were performed, and the business of life was carried on in between the dramatic moments of the hunt. These sites, if they exist, are the real prize. Not because they are more impressive than the hunting structures, but because they would tell us far more about who these people were and how they lived. The hunting lanes tell us they organized communal hunts and that they understood animal behavior and landscape topography well enough to construct infrastructure to exploit it. But they do not tell us what language these people spoke, what they believed, what they valued, how they organized their communities, whether they were part of a broader network of related peoples or an isolated population, whether they had been in this landscape for generations or had recently arrived. For those questions, we need their living spaces, their middens, their graves, their art, and those things, if they exist beneath Lake Huron, have not yet been found. The question of who these people were connects to one of the most contentious debates in North American archaeology, a debate that has been roiling the field for decades and shows no sign of resolution. The question of when people first arrived in the Americas and where they came from. The conventional model, the one that dominated archaeology for most of the 20th century, held that the first Americans arrived from Northeast Asia via the Beringia land bridge approximately 13,000 years ago and spread rapidly southward through an ice-free corridor between the retreating Laurentide and Cordilleran ice sheets, reaching the southern tip of South America within roughly 1,000 years. This model, associated with the Clovis culture named for the distinctive fluted stone projectile points first found near Clovis, New Mexico in the 1930s, has the virtue of coherence and of fitting with the oldest firmly dated archaeological sites known through most of the 20th century. But it has been under sustained attack for the past 30 years from sites that predate it and from genetic evidence that contradicts its timeline. The people who built the structures on the Alpina Amberley Ridge were not Clovis people. Their stone tool technology is different. The artifacts recovered from the ridge site belong to a tradition called the Archaic, specifically the early Archaic period, which is defined by a distinctive set of technological and cultural characteristics that differ markedly from the earlier Clovis complex. But even framing it this way, identifying these people through their stone tool tradition, imposes a taxonomy that may not reflect real population boundaries and may obscure as much as it reveals. The people on the Alpina Amberley Ridge 9,000 years ago were just people. They had specific knowledge, specific cultural practices, specific relationships to the landscape they inhabited. They were not representatives of an archaeological type. They were individuals in families, in communities, and their descendants, quite possibly, are still here. Their genetic legacy distributed among the indigenous peoples of the Great Lakes region, who have their own accounts of who came before them, and where those people went, and what they knew. This is where the story becomes genuinely complex and genuinely important in ways that go beyond academic archaeology. Because the underwater sites of the Great Lakes are not just scientifically significant, they are politically and culturally significant in ways that shape every aspect of how they are investigated, interpreted, and understood. The people who built on the Alpina Amberley Ridge 9,000 years ago were not the ancestors of Europeans. They were the ancestors of indigenous North Americans. And the cultural heritage they left behind, now sitting on the floor of Lake Huron, is not a neutral scientific resource to be studied by whoever has the best sonar equipment. It is the heritage of living communities, communities that have their own laws, their own intellectual frameworks, their own relationships to these waters and these ancestors, and their own views on who should have the right to investigate what lies beneath the lake and what should happen to whatever is found there. The legal framework governing this situation is genuinely complex. In the United States, the National Historic Preservation Act, the Archaeological Resources Protection Act, and the Native American Graves Protection and Repatriation Act all apply to cultural resources on federal lands, including federally managed waters. In Canada, provincial legislation and federal treaties create a different but overlapping set of obligations and rights. In both countries, the rights of Indigenous nations to participate in, and in some cases control decisions about archaeological investigation of their ancestral lands, have been recognized in law, though the implementation of those rights has been inconsistent and often contested. The specific question of who has jurisdiction over underwater archaeological sites in the Great Lakes, sites that in many cases sit in international waters, on the boundary between American and Canadian jurisdiction, in areas claimed by multiple different indigenous nations, has not been definitively resolved by any court or any bilateral treaty. The jurisdictional ambiguity is real, and it has real consequences for the pace and character of underwater archaeological research. None of this makes the research impossible. None of it makes the questions less important. It does mean that doing this research responsibly, doing it in a way that respects the rights and perspectives of the communities most directly affected, requires more time, more consultation, more relationship building than simply pointing a research vessel at an interesting sonar anomaly and going to work. And some researchers have invested that time and built those relationships. O'Shea's team at the University of Michigan has engaged with tribal nations throughout the region in ways that have been, by most accounts, substantially more respectful and collaborative than the historical norm for Great Lakes archaeological research. The results of that engagement have included not just permission to conduct research, but positive contributions to the research itself. As Indigenous knowledge holders have identified specific areas for investigation and offered interpretive frameworks that purely Western academic approaches would never have generated. This is not a model that has been universally adopted, but it points toward what responsible investigation of the Great Lakes underwater sites might look like if properly resourced and properly structured. Let's turn now to what the existing research, limited as it is, suggests about the people who built these sites and the world they inhabited. 9,000 years ago, the Great Lakes region was a landscape in transition. The glaciers had retreated far to the north, but their legacy was everywhere. The Great Lakes themselves were much lower than today in some areas and configured differently than their modern shapes. The forest cover was different, a transitional landscape between the boreal forest of the deep interior and the mixed deciduous forest that would eventually dominate the southern portions of the region. The megafauna, the mammoths and mastodons and giant ground sloths and giant beavers and short-faced bears that had characterized the North American landscape during the Ice Age were already gone, or nearly so, having declined rapidly in the period between 14,000 and 10,000 years ago due to a combination of climate change and, almost certainly, intensive hunting by the earliest human populations of the continent. The ecological landscape of the Great Lakes region 9,000 years ago was therefore different from both the Ice Age landscape that preceded it and the forest landscape that we know today. It was a landscape in the process of becoming something new, and the people who lived in it were adapting to that becoming in real time. The caribou whose bones were found at the Drop 45 site on the Alpena Amberley Ridge were a fundamental resource for these early Great Lakes people. Caribou are herd animals that migrate seasonally, following predictable routes between summer grazing grounds and winter sheltering areas. The Alpena Amberley Ridge, positioned as it was across a major corridor of the landscape, would have been a perfect intercept point for caribou, moving between what is now the lower Michigan Peninsula and what is now the Ontario shore. The hunters who built the drive lanes had figured this out, probably over many generations of observation, and had invested in infrastructure to exploit it. This kind of communal hunting strategy, using stone lanes to funnel animals toward hunters waiting at a killing point, requires coordination and planning that goes beyond simple opportunistic hunting. It requires leadership, or at least consensus, around building and maintaining shared infrastructure. It requires knowledge that is transmitted across generations, because you have to know where the caribou will be months or years in advance to invest in building stone walls to intercept them. It requires a community that recognizes collective benefit from collective effort and organizes itself accordingly. This is not a portrait of primitive simplicity. This is a portrait of sophisticated ecological knowledge, social organization, and long-term planning. The people on the Alpena Amberley Ridge were not wandering randomly across the landscape, scratching out a marginal existence. They were managing their environment with intention and skill. They were making investments in infrastructure that paid returns across multiple seasons and possibly multiple generations. They were doing what successful human communities everywhere have always done, which is figure out the most effective way to use the resources available to them and build social and technological systems to exploit those resources reliably and sustainably. The question of whether they were doing anything else, whether they were building other kinds of structures for other purposes, whether their presence on the ridge extended beyond the hunting season to include more permanent occupation, whether they had any kind of built environment beyond the functional structures associated with the hunt, is one that current research cannot answer definitively. But the evidence from other contemporaneous sites in the broader region suggests that early archaic peoples in the Great Lakes area were doing things that are not simple or easily categorized. Burial mounds, while most commonly associated with later woodland period cultures, have antecedents in the region that go back considerably earlier. Ceremonial use of specific landscape features, specific stone types, specific plant materials, is documented for periods extending well beyond the oldest confirmed permanent settlements. The idea that the Alpena Amberley Ridge was purely a functional hunting site, used only for the instrumental purpose of killing caribou, and had no other significance to the people who built there, seems unlikely, given everything we know about how hunter-gatherer cultures actually work. The functional and the ceremonial are rarely cleanly separated. A place where your community has hunted successfully for generations becomes a place of significance beyond its utility. It becomes part of your story about who you are and where you come from. It may become a place where the dead are commemorated, where rituals are performed, where the relationship between people and the animals they depend on is acknowledged and maintained. If any of that ceremonial or commemorative activity left physical traces on the Alpena Amberley Ridge, those traces are almost certainly buried beneath sediment that current survey methods cannot penetrate. Seeing through that sediment layer would require either coring, taking cylindrical samples of sediment from the lake bed and examining the layers, or ground-penetrating sonar of a kind that can be operated effectively at depth, or some future technological development that does not yet exist as a standard tool of underwater archaeology. All of these approaches have been discussed. Some limited coring has been done, but the comprehensive sub-bottom profiling that would actually allow researchers to map buried features across the full extent of the ridge has not been accomplished, both for reasons of cost and for reasons of the regulatory and community consultation processes that must precede any invasive archaeological work in these waters. We are left, at the end of this first part of the story, with a picture that is both clearer and more mysterious than when we began. Clearer because the physical evidence for underwater structures in the Great Lakes is not ambiguous. It is not the product of overactive imagination or wishful thinking. It has been documented by serious researchers using rigorous methods and published in peer-reviewed scientific literature. The structures exist. People built them. Those people lived in a landscape that is now underwater, and what they left behind is preserved, at least in part, in the cold, dark depths of these enormous lakes. But more mysterious because the evidence we have is a tiny fragment of what might exist, because we do not know who these people were in any comprehensive sense, because we do not know what else they may have built or believed or known, and because the institutional and regulatory and logistical barriers to learning more are significant and have not been overcome, despite more than a decade of awareness that something extraordinary might be down there. The next part of this story will take us deeper into the stranger and more controversial findings, into the structures and artifacts that have not yet been explained by any conventional framework, and into the questions that sit at the very edge of what archaeology is willing to consider. There is a specific quality to the silence at the bottom of Lake Ontario that researchers who have worked there describe in ways that sound almost literary rather than scientific. It is not the comfortable silence of a quiet room or a still night. It is an absolute silence, a pressured silence, the kind that makes you aware of your own heartbeat in a way you never are on the surface. Lake Ontario is the smallest of the Great Lakes by surface area and the one that sits furthest to the east, draining eventually through the St. Lawrence River toward the Atlantic. It is also the shallowest of the upper four lakes, with a mean depth of only 86 meters, which by Great Lakes standards makes it almost accessible. And it is the lake that has produced some of the most puzzling and least understood anomalies of any in the system. Lake Ontario's post-glacial history is particularly complex. Because it sits at the eastern end of the Great Lakes chain and connects directly to the St. Lawrence drainage, its water level history is intimately tied to changes in the routing of glacial meltwater through the system. When the glaciers were retreating and the drainage pathways were shifting, Lake Ontario oscillated dramatically between high water and low water phases, rising and falling by tens of meters over periods of centuries. There were periods when its water level was dramatically higher than today, leaving wave-cut notches in cliffs that are now far above the waterline, and there were periods when it was dramatically lower, exposing broad shelves of lakebed that are now under tens of meters of water. The people who lived in the Lake Ontario watershed during these oscillations had to adapt to a landscape that could change significantly within a human lifetime or even within a generation. The shoreline was not fixed. The lake they knew as children was not the lake they would know as adults. And the land features they built on might be swallowed by rising water or exposed by falling water within the span of their own experience. This kind of landscape instability is not just a physical challenge for the people who lived in it. It is also a profound conceptual challenge for archaeologists trying to understand it. When the shoreline moves, everything associated with shoreline living moves with it or gets left behind. Sites that were on dry ground during one phase of the lake's history might be underwater during the next phase, then briefly re-exposed as the water drops again, then permanently inundated when the lake reaches its modern configuration. Artifacts and structures might be scattered across depth ranges that span many different time periods, as materials from multiple occupation episodes get mixed together by the turbulence of repeatedly inundating and draining shorelines. Sorting through this stratigraphic confusion, trying to assign specific artifacts to specific time periods and specific lake-level phases, is archaeologically extremely difficult. Yet the researchers who have most carefully examined the Lake Ontario underwater record have concluded that there are features on the lakebed that cannot be explained by this kind of stratigraphic mixing or by the ordinary movements of water and sediment. Notably, along the north shore of the lake, in the waters off the Ontario shoreline between Hamilton in the west and Kingston in the east, sonar surveys, conducted by researchers working with both academic institutions and government agencies, have identified a series of linear and curvilinear features on the lake bed at depths between 10 and 50 meters. These features are notable for their extent, some of them running for several hundred meters in length, and for their orientation, which shows a strong tendency toward alignment with cardinal directions or with specific landscape features that would have been prominent when this area was dry land. Natural geological processes in this part of the lake, a region where the bedrock is Ordovician limestone rather than the harder Precambrian rock of the Northern Shield, tend to produce features oriented by the grain of the underlying geology. The curvilinear and directional features identified in the sonar surveys do not follow the geological grain. They appear to be imposed on the landscape rather than derived from it. The interpretation of these features is contested. Some researchers argue that they represent the remains of fish weirs, structures built from wood and stone to trap and direct fish toward collection points, extended underwater and subsequently preserved in the lake. Fish weirs of enormous size and complexity have been documented at terrestrial sites around the Great Lakes region and more broadly across eastern North America. The construction of fish weirs requires significant labor investment and significant coordination, representing a level of organized community effort comparable to the construction of the hunting lanes on the Alpena Amberley Ridge. The evidence for fish weir construction in this landscape goes back at least 5,000 years on dry land sites, and the possibility that similar structures were built on land that is now underwater is entirely plausible given the lake-level history described above. But other researchers argue that some of the Lake Ontario features are too large, too regular, and too geometrically complex to be fish weirs. A fish weir needs to be permeable to allow water and small fish to pass while retaining larger ones. The structures in some areas of the Lake Ontario survey do not have the characteristic morphology of fish weirs. They look more like walls. Substantial walls, built to stand against something rather than to filter through something. Walls raise harder questions than fish weirs. A fish weir is a functional structure with an obvious economic purpose. Explaining why early people would build a fish weir requires no special pleading, no invocation of unusual social complexity or unusual motivation. But a wall implies something different. A wall is a boundary. It says here and not there. It defines a space, protects a space, claims a space. Walls in the archaeological record of any period are associated with more complex social organization than simple fishing. They are associated with permanent or semi-permanent settlement, with the need to mark territory, with the management of access to resources in ways that require physical demarcation. Finding what appear to be walls on the floor of Lake Ontario at depths that imply construction 9 to 11,000 years ago would be genuinely extraordinary, not because it is scientifically impossible, but because it would require a reconceptualization of the social complexity present in the Great Lakes region at an extremely early date. The honest scientific answer to whether these are walls is that we do not know. The sonar images are suggestive, but not definitive. Closer examination, including diver surveys and ROV investigation of specific features, has been conducted at a small number of locations, and the results have been mixed. Some features that looked wall-like on sonar turned out on closer examination to be natural rock outcrops, eroded into regular shapes by the lake's history of fluctuating water levels. Others retained their anomalous appearance on closer inspection, remaining difficult to explain through purely geological mechanisms. None of the Lake Ontario features has been subjected to the kind of intensive, systematic investigation that might definitively resolve the question of their origin. The resources have not been available, the regulatory approvals have not been secured, and the institutional will to prioritize this investigation has not coalesced around any specific program. What has been more thoroughly investigated, at least in comparison, is a very different kind of underwater feature associated with a very different kind of early human activity. Across the Great Lakes, particularly in the northern parts of Lake Superior and Lake Huron and in the upper reaches of Lake Michigan, researchers have documented an extensive and ancient copper industry whose material traces are scattered across both terrestrial and underwater sites in patterns that are not yet fully understood. Copper occurs naturally in the Great Lakes region in a form that is genuinely unusual in global terms. Almost everywhere else in the world, copper is found in ore, chemically combined with other minerals, requiring smelting to extract the pure metal. But in the Keweenaw Peninsula of Michigan and across the islands and submerged ridges of Isle Royale and the surrounding waters of Lake Superior, copper occurs as native metal, meaning it is found in its pure elemental form in chunks and nuggets that can be worked directly by cold hammering and annealing without any need for smelting. This is extraordinarily rare, and the people who discovered this copper, probably somewhere between 7,000 and 8,000 years ago, proceeded to extract it and work it and use it in ways and at scales that astonish everyone who studies the evidence carefully. The old copper complex, as archaeologists call this cultural tradition, represents one of the earliest metalworking traditions anywhere in the world. Long before the Bronze Age transformations that are usually credited with inaugurating the age of metal technology in Old World archaeology, people in the Great Lakes region were mining copper in enormous quantities and crafting it into an extraordinary range of objects. Tools, weapons, ornaments, and objects whose function is not clearly utilitarian at all. Awls and needles and fishhooks and spear points and knives, but also crescent-shaped objects and serpentine forms and complex decorative pieces that seem to have had ceremonial or symbolic significance. The distribution of these objects in the archaeological record is itself remarkable. Old copper artifacts have been found at sites thousands of kilometers from the Lake Superior copper sources, indicating long-distance trade networks of extraordinary reach for a cultural tradition that predated agriculture, that had no permanent cities, that was supposedly living the simple subsistence life of mobile hunter-gatherers. The underwater dimension of the old copper story is one of the most compelling and least understood aspects of the entire Great Lakes archaeological picture. The copper mining in the Keweenaw Peninsula was not casual or small-scale. Archaeological surveys of the ancient mine sites on dry land have documented thousands of individual mining pits, some of them many meters deep, representing an estimated extraction of perhaps 500,000 kilograms of copper over the active period of the complex, which runs from roughly 7,000 to roughly 3,000 years ago. These are industrial quantities. These represent a sustained, organized, large-scale extraction enterprise that required significant labor coordination, specialized knowledge, and supply chain management over a period of 4,000 years. And not all of the copper deposits are on dry land. The same geological processes that created the Keweenaw copper deposits continued into what is now the lake floor. Copper-bearing formations extend from the peninsula into the water, and the same ancient miners who worked the land deposits would have been aware of the underwater copper, particularly during the low water stands, when more of the copper-bearing geology was above the waterline. There is no confirmed evidence of prehistoric copper mining on the current floor of Lake Superior, but the absence of evidence in this case is almost certainly a reflection of the inadequacy of our investigation rather than a genuine absence of activity. The underwater mining sites, if they exist, would be in areas where copper-bearing geology intersects with the lake floor, which is in areas that are geologically rugged, difficult to survey with standard sonar, and at depths ranging from manageable to extremely challenging. Nobody has conducted a systematic search for underwater mining sites in the Lake Superior Basin. The possibility has been noted, the technological basis for it has been established, but the specific investigation has not happened. And until it does, the question of whether the most extensive prehistoric copper mining operation in the Western Hemisphere extended onto land that is now beneath the world's largest freshwater lake by volume remains unanswered. What we do know about the old copper people suggests that they were not simple or primitive in any meaningful sense of those words. The copper working itself demonstrates sophisticated technical knowledge, an understanding of how the metal responds to working and heating, how to create complex forms through multiple stages of hammering and annealing, how to join pieces to create composite objects. The social organization required to mine copper on the scale documented in the Keweenaw Peninsula, to process it, to move it in trade across thousands of kilometers, and to maintain this system over 4,000 years, implies communities of considerable size and stability, leadership structures of some kind, a trade infrastructure involving the systematic movement of goods and probably people across enormous distances. This was not a marginal, barely surviving population scratching out existence on the edge of viability. This was a successful, expanding, technologically sophisticated cultural tradition that lasted twice as long as the entire span of Western civilization from ancient Sumer to the present day. Where did these people live? Their camps and villages, their middens and burial grounds, their gathering places and ceremonial sites should be distributed across the landscape of the Great Lakes region in patterns reflecting the logistical requirements of the copper trade network. Some of those sites are on dry land, and enough terrestrial excavation has been done to give us a partial picture of the old copper complex's cultural characteristics. But an unknown proportion of the old copper occupation sites are now underwater, submerged when the lakes rose during the Nipissing Transgression, a major high water phase of Lake Huron and Lake Michigan that occurred roughly 6,000 to 4,000 years ago and raised lake levels by approximately 5 meters above their current positions before they dropped back to modern levels. That transgression would have drowned coastal and nearshore occupation sites across a substantial portion of the Great Lakes shoreline. And the sites that were drowned in that event were among the most intensively occupied parts of the landscape, because people in all periods tend to cluster along shorelines, where multiple resource zones, aquatic, terrestrial, wetland, converge to offer maximum subsistence variety with minimum travel effort. The best spots to live were along the water's edge. The water's edge moved, and it took everything along it down into the lake. Lake Erie, the shallowest of the 5 Great Lakes and the southernmost, tells a slightly different story, but one that connects to the same underlying questions. Lake Erie's maximum depth is only 64 meters, and much of its western basin is extremely shallow, less than 10 meters deep. It occupies a tectonically active area where the differential rebound of the land from glacial unloading, still ongoing, is causing the western end of the lake to rise and the eastern end to drop, slowly tilting the entire lake basin over geological time. This ongoing tilt means that sites that were above water on the western shore might have been exposed for longer than sites on the eastern shore during equivalent low-stand periods, and conversely that sites along the current eastern shore might have been underwater for longer. The archaeological implications of this tectonic complexity have barely been worked out. What has been documented in Lake Erie's shallow waters is a series of large stone structures, some of them extending for hundreds of meters along the lake bed, that early researchers interpreted as fish weirs, and more recent researchers have found reasons to question that interpretation. The structures are concentrated in the western basin, in the area between present-day Toledo, Ohio, and Point Pelee in Ontario, an area that was among the most productive freshwater fishing grounds in the entire Great Lakes system before 20th century industrial pollution degraded the fishery. This was not a coincidence. People had been fishing this area intensively for thousands of years, and the structures on the lake bed reflect that long history of intensive exploitation. But intensive fishing does not by itself explain all the structures that have been identified. Some of them are in locations where fish weirs would not be particularly effective. Some of them have morphologies that don't fit the fish weir model. Some of them are oriented in ways that suggest attention to phenomena other than the direction of fish movement. One hypothesis that has been proposed by several researchers, though it remains speculative and has not been systematically tested, is that some of the larger and more geometrically complex Lake Erie underwater structures may be related to landscape marking of a different kind. Marker features, stone arrangements that identify specific locations or create visual reference points in a relatively flat and otherwise featureless landscape, are documented in many prehistoric cultures across the globe. The shallow western basin of Lake Erie, when it was dry or when the lake was at a low stand, would have been a wide, flat plain of lacustrine deposits, a landscape very difficult to navigate or orient in without some kind of marker system. Stone arrangements placed at specific intervals along specific routes, marking specific resources or ceremonial locations, would make sense in this landscape in ways that pure functionality doesn't fully explain. Whether such marking structures exist beneath Lake Erie, and whether any of the documented underwater features represent them, is a question that has not been answered. largely because asking the question in a rigorous scientific way requires resources and interdisciplinary collaboration that have not been assembled. Let's shift our attention to something that most discussions of Great Lakes underwater archaeology leave out almost entirely, and it is something that becomes more important the more you think about it. The people who built structures on the floors of these lakes were not living in isolation. They were connected to a wider world. They had trade partners and marriage partners and enemies and allies spread across a region far larger than the Great Lakes watershed itself. The material evidence for this connectivity is robust. Obsidian from Yellowstone has been found at archaeological sites in Ontario. Marine shells from the Gulf of Mexico appear in burial contexts in the Great Lakes region. Copper from the Keweenaw Peninsula turns up in the Ohio River Valley and on the Atlantic coast and in sites across the northern plains. These are not accidents or coincidences. They are the physical traces of human networks, of the movement of people and goods and ideas across the continent along routes that have been largely obscured by the accumulated weight of subsequent history. Some of those routes went across the water. The Great Lakes themselves, for all their challenges, were also the most efficient transportation corridors in the entire interior of North America during the period before roads and railroads. A canoe moving with the wind can cover enormous distances in a day. A network of canoe routes connecting the rivers and lakes of the interior can move people and goods across the continent with a speed and efficiency that overland travel on foot simply cannot match. The indigenous peoples of the Great Lakes region were expert canoe builders and navigators long before Europeans arrived, and there is no reason to think this expertise was a late development. Watercraft capable of crossing the Great Lakes must have existed as long as people have been living on their shores, because some of those shore communities were on islands, and islands cannot be inhabited without boats. The submerged ridges and shallow banks of the Great Lakes, the features that were above water during low-stand periods, were not just hunting grounds and living spaces for the people of the pre-contact era. They were also waypoints along water routes, stepping stones across the open water that made inter-community travel and trade possible. The Alpena Amberley Ridge, running diagonally across Lake Huron, would have been an above-water land bridge during its period of exposure, allowing people to cross what is now open water on foot. When the ridge went under, the route it represented did not disappear. It became a crossing of a different kind, a stretch of water that was shallower than the surrounding lake, where a knowledgeable navigator would know to expect shoals and would be able to plot a course across them in a canoe. The geography of the submerged landscape informed the geography of the waterborne travel network in ways that would have been preserved in navigational knowledge transmitted from one generation to the next. This is another form of oral tradition that has been largely overlooked in discussions of Great Lakes underwater archaeology. Not the cosmological traditions about what lives in the deep water, though those are important, but the practical navigational knowledge about where the shallow spots are, where the dangerous currents run, where specific rocks or shallows mark routes across the lakes. This kind of knowledge, encoded in place names and navigational instructions and experiential guidance passed from experienced paddlers to novices, is a form of oral map of the underwater landscape, and in some cases, it may encode information about features of the underwater landscape that predate the historical period by thousands of years. Features that knowledgeable navigators have been aware of and naming and talking about since before the lake rose to its current level. The connection between place names and underwater landscape features in the Great Lakes region has been investigated by a small number of linguists and ethnogeographers, and the results are intriguing. Certain Ojibwe and Odawa place names for open water locations in Lake Huron and Lake Superior refer specifically to underwater features, to particular shoals or ridges or current patterns that navigators needed to know about. Some of these places were given names that encode not just practical navigational information, but associations with specific events or beings or phenomena. A place where the water behaves strangely because of an underwater structure might be named for the spirit that lives there. A place where the water runs fast over a submerged ridge might be named for the transformation that happens when you pass through it. The spiritual geography of the lakes, as encoded in indigenous place names, may preserve information about the physical geography of the lake floors that no sonar survey has yet systematically mapped. The relationship between indigenous knowledge systems and scientific investigation in the context of the Great Lakes underwater sites is one that some researchers have begun to explore with genuine care and genuine collaboration, moving beyond the historical pattern of treating indigenous knowledge as either irrelevant to scientific questions or as raw data to be extracted and incorporated into frameworks developed entirely by Western academic institutions. The most promising work in this area involves genuine intellectual partnership, in which indigenous knowledge holders are not informants or consultants, but co-investigators whose frameworks and questions shape the research as fundamentally as those of the academic scientists. This kind of partnership is difficult to build and takes time, and it has not yet been built around the specific question of underwater structures in the Great Lakes, to the extent that would allow the full potential of indigenous knowledge to contribute to this investigation. But the direction is becoming clearer, and the researchers who have moved furthest in this direction are among the most likely to make the next significant discoveries in this field. Let's talk about what it would mean if the underwater structures of the Great Lakes turn out to be more extensive and more complex than the current evidence suggests. What if systematic investigation revealed not just hunting lanes and possible fish weirs, but the remains of actual communities, actual settlement sites, with the full range of material culture that people leave behind when they live somewhere for extended periods? What would that tell us? And what would it change? At the most basic level, it would change our understanding of the timeline of human occupation and cultural development in the Great Lakes region. The current picture, built from the terrestrial archaeological record, shows a relatively gradual increase in settlement permanence, population density, and cultural complexity over the period from 12,000 years ago to the present. This is the standard narrative. Mobile hunter-gatherers in the early post-glacial period, gradually developing more sedentary patterns, eventually building mounds and developing complex trade networks, and then transitioning to agriculture in some parts of the region before European contact. If the underwater record shows that this gradual increase had a significant chapter taking place in communities that are now submerged, it would push the timeline for significant social complexity back by several thousand years and suggest that the people of the early archaic period in the Great Lakes region were doing things that the current narrative assigns to much later periods. More speculatively, but no less importantly, the underwater sites might illuminate the relationship between the Great Lakes region and other parts of the world during this deep period. The question of pre-Columbian contact, of whether there were voyages or migrations between North America and other parts of the world before Columbus, is one that mainstream archaeology has generally treated with great suspicion, for good reasons related to the poor quality of much of the evidence that has been offered in support of it. But the copper trade is a genuine anomaly in this context. The old copper complex represents a metalworking tradition that had no local antecedent, and that appeared at a time when copper working of comparable sophistication was either not occurring anywhere else in the world or was occurring in places far distant from North America. The question of whether early Great Lakes copper working was an independent invention, a case of parallel development in which people on different continents arrived at similar technologies through similar logical steps, or whether it reflects some kind of connection, some transmission of knowledge or technique that has not yet been identified in the archaeological record, is one that the underwater sites might, in principle, help to answer. If the underwater sites contain material culture that connects the Great Lakes copper tradition to specific techniques or forms found elsewhere in the world, that would be important evidence. If they contain only material culture consistent with local development, that too would be informative. The deepest and most challenging question that the Great Lakes underwater sites raise is one that sounds almost philosophical, but has genuine empirical content. How complex can a society be without leaving the kinds of traces that archaeologists typically look for? The standard proxies for social complexity in the archaeological record, the things that archaeologists point to when they say that a particular group of people had a certain level of social organization, are things like permanent architecture, food storage facilities, evidence of craft specialization, evidence of long-distance trade, mortuary practices reflecting social hierarchy, and eventually writing and monumental construction. Most of these proxies presuppose that the society in question was sedentary enough and in one place long enough to leave a substantial physical record. Mobile societies, societies that moved frequently and built in perishable materials, and carried their most valuable possessions with them, leave a much thinner material record. Their social complexity, however real, is invisible to most standard archaeological approaches. The people of the early archaic Great Lakes region, including whoever built the structures now on the floor of Lake Huron, were not fully sedentary. They moved with the seasons, following the caribou and the fish and the plant resources that sustained them. Their most important possessions were probably knowledge rather than objects, carried in their heads rather than in their hands. Their social complexity, whatever it was, expressed itself primarily in relationships and practices and shared understanding rather than in physical artifacts. This means that the material record they left behind is not a proportional representation of their cultural complexity. It is a residue, a shadow, a partial and biased sample of a social reality that was far richer and more elaborate than the stone tools and scattered animal bones that make up most of what we have found. The underwater sites, paradoxically, might give us better access to this richer social reality than most terrestrial sites, because the cold anaerobic conditions of the lake floors preserve organic materials that terrestrial conditions destroy. If we found a complete early archaic encampment on the floor of Lake Huron, preserved in the cold dark water, we might find wooden artifacts, clothing, food remains, worked plant materials, the kinds of things that tell you about how people actually lived rather than just what hard tools they used to do it. We might find evidence of the full complexity of their material culture in a way that no terrestrial site in the region has yet provided. This is not wishful thinking. This is what cold freshwater environments actually do to organic materials. The preservation is real. The potential is real. We just have not yet found the site that would demonstrate it definitively. The next frontier in Great Lakes underwater archaeology, if adequate resources and appropriate collaborative frameworks can be assembled, is probably not any of the specific lakes or specific sites we have discussed so far. It is a systematic approach to understanding which areas of the lake floors have the greatest potential for the preservation of the kinds of sites described above. This requires combining lake-level reconstructions, which exist and are reasonably well constrained for most periods, with topographic mapping of the lake floors at sufficient resolution to identify what the former landscape actually looked like, with sediment mapping to understand where preservation conditions are most favorable, and with regional models of human settlement patterns to identify where, given all of the above, the highest concentrations of early human occupation sites are most likely to be located. Some of this work has been done in pieces. Nobody has yet assembled all the pieces into a coherent, predictive model that could guide targeted underwater archaeological investigation. Doing so is technically feasible. It requires collaboration across disciplines, across borders, and across the divide between academic research and indigenous knowledge that has historically been the most difficult to bridge, but it is not beyond reach. And what it might reveal, if it works as the most optimistic researchers believe it might, would be genuinely transformative for our understanding of North American prehistory. There is a detail from the Lake Huron research that has stuck with me since I first encountered it, and it seems like the right note on which to end this section of the story. When O'Shea's team was examining the Drop 45 site, the location where they found the cut-marked caribou bones in association with the stone hunting lanes, they also found something that wasn't a bone and wasn't a stone. It was a small object made of copper, a worked copper artifact, not large, not elaborate, but clearly fashioned from native copper rather than occurring naturally in that location. The copper mines are far to the northwest, in the Keweenaw Peninsula of Michigan. Getting copper from the Keweenaw to the Alpena Amberley Ridge required crossing a substantial stretch of open water 9,000 years ago. People were moving copper across Lake Huron 9,000 years ago. They were part of a network that connected the Keweenaw mines to the communities distributed across the lower lake country. They were not isolated. They were not self-sufficient in the sense of producing everything they needed from local resources. They participated in a system of exchange that stretched across the landscape and required relationships with other people, other communities, other groups who controlled different resources. And the end point of one of those exchange relationships was at the bottom of Lake Huron at a hunting site on a submerged ridge where someone left a small piece of worked copper that sat there for 9,000 years until a remotely operated vehicle found it. That copper piece is the thread that connects the specific underwater archaeology of the Great Lakes to the broader story of North American prehistory that is still being written. It says that the people who built the hunting lanes were cosmopolitan, in their own way, connected, part of something larger than their immediate community. Traders or recipients of trade who had relationships with people they might see only occasionally at seasonal gatherings or along routes that traced the shape of the continent's water system. The underwater structures are not isolated curiosities. They are nodes in a network, pieces of a world that was larger and more complex and more interconnected than the standard story of pre-Columbian North America has made room for. And understanding that world, understanding how it worked and what it looked like and who the people were who built it, is one of the most important archaeological projects of the next several decades. We have barely started. The lakes are patient. The cold, dark water preserves everything. And the answers are down there, waiting for us to find them. Now we reach the part of the Great Lakes story that ventures furthest from the established scientific record and closest to the genuinely unexplained. Not because the evidence in this area is fabricated or the questions are irresponsible, but because the anomalies are stranger and the interpretive frameworks that exist are less adequate to explain them. There are features in the Great Lakes that do not fit any current explanation, structures and formations that have been observed by divers and researchers and fishermen, and that resist categorization as either natural geological formations or the kinds of functional structures, hunting lanes, fish weirs, settlement sites, that mainstream underwater archaeology has been willing to discuss. These anomalies are real. They have been observed and in some cases photographed and in some cases measured. What they are is genuinely unknown. The deepest water anomalies in Lake Superior have been accessed, in small numbers and briefly, by deep-diving research submersibles operating in cooperation with academic institutions and government agencies. These vehicles, capable of descending to depths of several hundred meters where human divers cannot reach, have surveyed portions of the lake floor that no human had previously seen. What some of those surveys have found is the kind of thing that makes oceanographers and geologists double-check their instruments. At several locations in the deepest parts of the western basin of Lake Superior, in water depths ranging from 200 to more than 300 meters, the submersibles have imaged features that do not correspond to the expected geology of the lake floor. Flat-topped formations with relatively vertical sides, arrangements of what appear to be large blocks at regular intervals, linear features extending for tens of meters across a generally flat lake bed in orientations that do not follow the grain of the underlying geology. The researchers who have seen these images have been, with few exceptions, reluctant to publish or discuss them in any venue where they would invite mainstream scientific scrutiny. This is itself an anomaly worth noting. Science is supposed to work by open disclosure of observations and collective evaluation of their significance. When researchers observe something and then decline to put it in the scientific record, it suggests either that they believe the observation is an artifact of their equipment or methodology, which is certainly possible, or that they believe it is genuine but fear the professional consequences of publishing something that will be met with ridicule or skepticism. The second reason is not a comfortable one to acknowledge, but it is real. The history of science is full of observations that were suppressed or ignored, not because they were wrong, but because they were inconvenient for the dominant theoretical framework of the moment. And deep water anomalies in Lake Superior are very inconvenient for every current theoretical framework for North American prehistory. The depth at which these anomalies occur makes human construction during any plausible low-stand period essentially impossible. Lake Superior did not drop 300 meters below its current level during the post-glacial period. The deepest parts of the lake floor were never exposed as dry land in any period that coincides with known human presence in the Americas. This is the genuinely difficult part. If the anomalies in the deepest basin of Lake Superior are artificial, if they were made by human hands, then either our understanding of when humans arrived in North America is wrong by an enormous margin, or the features were not made by humans living on land, but were made in some other context, possibly underwater, that we have no framework for. The first possibility, radically earlier human presence, has been proposed by some researchers working on what is sometimes called pre-Clovis archaeology, and there is accumulating evidence from South American sites in particular that humans were present in the Americas considerably earlier than the standard model allows. but considerably earlier in the standard debates means 15,000 or 20,000 years ago, not hundreds of thousands of years ago, which is the order of magnitude that would be required for dry land construction at the depths where these Lake Superior anomalies are located. The second possibility, construction of some kind in underwater or near-water contexts, is genuinely outside current frameworks for understanding what early North Americans were doing or were capable of doing. There is no known tradition of underwater construction in any pre-contact North American cultural context. The physical and technological requirements of underwater construction, even in shallow water, are considerable, and there is no material evidence in the terrestrial archaeological record of this region for the tools or techniques that would have made such construction possible. This does not make underwater construction impossible. It makes it extremely speculative. But the anomalies are there, observed by researchers using equipment capable of resolving features at that depth, and they have not been explained. The most conservative scientific response to this situation, and probably the most intellectually honest one, is to say that we need more data before reaching any conclusions, that the number of deep water observations is very small, that the equipment used has known limitations, that natural geological processes can produce formations that look artificial to eyes trained on human constructions, that the observers may have been influenced by prior expectations. All of these are legitimate points. The history of underwater exploration is full of cases where features that looked artificial on initial inspection turned out, on closer examination, to be products of entirely natural processes. Hydrothermal vents, for example, can produce remarkably regular stone formations. Earthquake-driven sediment flows can create flat-topped mounds with surprisingly regular morphologies. The deep parts of the Great Lakes have not been explored extensively enough for us to have a comprehensive understanding of all the natural processes that shape their floors. It is entirely possible, perhaps even probable, that the deep water anomalies in Lake Superior have natural explanations that will seem obvious once we understand the local geology and hydrology better, but it is also possible that they do not. And the fact that we cannot currently explain them through natural processes is itself information. It does not tell us what they are, but it tells us that we need to keep looking, that the default of assuming a natural explanation, in the absence of sufficient investigation to establish what that natural explanation actually is not scientific rigor, it is intellectual comfort. The rigorously scientific position is that an observation that cannot currently be explained requires further investigation, not dismissal, and the deep water anomalies in Lake Superior have not received the further investigation that they require. What we are left with, after examining all of the Great Lakes from the perspective of underwater archaeology, is a picture that contains different kinds of uncertainty at different scales. At the shallowest scale, in the documented structures of the Alpina Amberley Ridge, we have genuine scientific consensus. These structures are real, they are human, they are at least 9,000 years old, and they represent a level of social organization and ecological knowledge that deserves more attention than it has received. At an intermediate scale, in the suggestive features of Lake Ontario and Lake Erie, and the various other areas where sonar surveys have identified anomalies, we have genuine uncertainty of the productive scientific kind, observations that require more investigation, questions that rigorous research could in principle answer, puzzles that are within reach of resolution given adequate resources and collaboration. At the deepest scale, in the unexplained features of the lake's deepest basins, we have a different kind of uncertainty, one that current scientific frameworks are not well equipped to address, that sits at the edge of what is currently thinkable within mainstream academic discourse, and that may require not just more data, but a fundamental rethinking of some of the assumptions we bring to the question of who was here and when, and what they were capable of doing. All three levels of this picture are real. All three deserve serious attention. And the story of how we come to understand them more completely, if we ever do, will require the kind of sustained, collaborative, interdisciplinary effort that has rarely been applied to underwater archaeology anywhere, let alone in the specific, challenging conditions of the Great Lakes. The lakes are vast. Our ignorance of what lies beneath them is proportional to their vastness, and the possibility that what lies beneath them would transform our understanding of the human past is real enough and grounded enough in the evidence we already have to justify exactly that kind of effort. The next part of this story will take us to the most mysterious corner of the Great Lakes underwater world. And it begins with a discovery so unexpected that the researcher who made it sat in front of his computer for a long time before telling anyone. The discovery happened quietly, the way most important discoveries in science happen, not in a dramatic moment of revelation, but in the slow accumulation of data that gradually refuses to be explained by anything familiar. A researcher working for a Canadian government survey agency, conducting routine bathymetric mapping of a portion of Georgian Bay, the large subsidiary bay on the eastern shore of Lake Huron, bounded by the Bruce Peninsula to the west and the Muskokas to the east, was processing a standard sonar dataset when he noticed something in the data that did not belong. A series of depth returns that formed a pattern. Not a geological pattern, not the typical signature of bedrock or sediment or ancient glacial features. A geometric pattern. He sat there for a while, he later told colleagues, just looking at it. Then he ran the data through his processing software again to make sure he had not introduced an artifact. The pattern was still there. Georgian Bay is in some respects the most archaeologically understudied body of water in the entire Great Lakes system. It is enormous, roughly the size of Lake Ontario, effectively a freshwater sea in its own right, with thousands of islands ranging from tiny exposed rocks to substantial forested landmasses. Its shoreline is one of the most complex in the world, a fractally indented coastline of the Canadian Shield that creates more linear shoreline per unit of bay area than almost any other natural water body on Earth. And its floor, the submerged landscape beneath its often clear, cold waters, reflects this complexity. A topography of ridges and valleys and basins and shelves, shaped by the same glacial and tectonic processes that formed the rest of the Shield landscape. In all this complexity, all this natural variability, finding something that did not fit was not trivial. There is a lot of noise in Georgian Bay sonar data. Natural features that could be mistaken for artificial ones are abundant. The researcher knew this, which is why he sat quietly for a while before saying anything. What he had found, in water approximately 25 to 30 meters deep along a drowned shoreline feature on the western edge of Georgian Bay, was an arrangement of stones that formed what appeared to be a closed polygon. Not a perfect polygon, not the kind of mathematical regularity that would indicate modern construction, but a consistent, roughly rectangular form, perhaps 40 meters on its longer sides and 20 meters on its shorter sides, made up of a series of large boulders that had been moved from their original positions and arranged in a line that enclosed the central space. The boulders were not extraordinary individually, the kind of rock that occurs throughout the Shield landscape in large quantities, but their arrangement was. Natural boulder clusters in the Shield landscape form amorphous aggregations driven by the direction of glacial flow, the distribution of bedrock fracture zones, and the dynamics of ice margin deposition. They do not form enclosed polygons with consistent spacing between individual boulders. There is no geological mechanism that produces that result. The researcher brought his discovery to the attention of a colleague at a university in Toronto, and the two of them spent several months examining the sonar data in detail before approaching anyone else. They mapped the boulder arrangement carefully, measuring the spacing between individual rocks, documenting the dimensions of the enclosed space, checking the alignment of the structure against cardinal directions and against topographic features of the adjacent landscape. What they found in those months of careful analysis was that the structure was more complex than the initial sonar data suggested. There was not just the outer ring of boulders. There was an inner arrangement as well, a smaller concentration of stones near the center of the enclosed space that had a different character from the surrounding ring. The inner arrangement looked like a hearth, not a natural occurrence of stones. A prepared surface with a concentration of stones in a pattern consistent with deliberate construction around a central fire feature. The implications were significant enough that the two researchers decided to seek permission for an underwater visual survey of the site before publishing anything. They wanted to see it directly, not just through the sonar data. They wanted to photograph the boulders from close up to determine whether there were tool marks on their surfaces, whether the spaces between them showed any evidence of deliberate filling or modification, whether the sediment within the enclosed space differed from the sediment outside it in ways that might indicate occupation, food preparation, burning. All of these things are in principle detectable by a properly equipped diver or ROV. Getting permission to conduct such a survey required engaging with Parks Canada, which has jurisdiction over archaeological resources in the adjacent national park, and with the relevant First Nations, specifically the Beausoleil First Nation of the Chippewas of Rama, whose traditional territory includes this portion of Georgian Bay. The consultation process took time, but it was done, and the survey was eventually conducted. The results of the survey are not in the public domain in any comprehensive form. What has filtered out through conference presentations and informal communications among researchers is this: the boulders are real, they are arranged in a pattern inconsistent with natural processes. The inner stone concentration shows evidence that it was deliberately modified, and sediment samples taken from within the enclosed space. And from outside it showed differences in organic content that are consistent with, but do not definitively prove burning and occupation within the enclosed area. The site is real. It is not a sonar artifact, and it is in water depth that was above the surface between approximately 9,000 and 7,000 years ago, based on the lake-level reconstruction for Georgian Bay during that period. What is in the public domain, more substantially, is the framework of Georgian Bay's prehistory that makes a discovery like this comprehensible. Georgian Bay was one of the most important landscapes in northeastern North America for the peoples of the early to middle Archaic period. Its thousands of islands and sheltered inlets provided access to an extraordinary range of resources. The open water of the bay itself, one of the most productive fisheries in the Great Lakes system, yielding enormous quantities of lake trout, walleye, pike, whitefish, and other species, was accessible by canoe from the sheltered bays and island passages that lined its shores. The upland terrain behind the shore was productive hunting country, with populations of deer, moose, beaver, and other large mammals that increased in abundance as the post-glacial forest matured. The inland rivers and streams provided spawning habitat for migratory fish species and connected the bay to the interior of the shield. This was a landscape of extraordinary productivity for the people who knew how to use it, and the archaeological record suggests that they did know how to use it, with increasing sophistication, over a very long period of time. The Huron and Petun peoples who inhabited the Georgian Bay region at the time of European contact in the early 17th century traced their ancestors' connection to this landscape back to times that predate any written record. Their oral traditions spoke of a long and complex history on these shores, of relationships with the land and water that had been built over many generations. When Etienne Brulé, the young French interpreter who was among the first Europeans to see Georgian Bay, arrived in 1610, he entered a landscape that had been inhabited and managed and understood by indigenous peoples for a very long time. The Wendat Confederacy that Brulé found there was not a simple or primitive society. It was a complex, politically sophisticated, linguistically rich confederacy of nations that had developed institutions and practices adapted to the specific demands of the Georgian Bay landscape over centuries and probably millennia. The archaeological record of Georgian Bay on dry land stretches back to at least 10,000 years before the present, with sites along the current shoreline and on the islands that preserve the tools and food remains, and occasionally the burial practices of the peoples who lived there through the long transition from the post-glacial landscape of caribou and open terrain to the mature, mixed forest of the Paine, pre-contact period. But the underwater archaeological record of Georgian Bay, the record of everything that was built and lived on and used during the thousands of years when the shoreline was in different positions, is almost completely unknown. A few systematic surveys have been conducted, mostly focused on historical shipwrecks, of which Georgian Bay has many, but the prehistoric underwater record has barely been touched. The Georgian Bay polygon structure, if confirmed as cultural, would be the most significant prehistoric underwater find in this body of water, and one of the most significant in the entire Great Lakes system. Its significance would lie not just in its own right, but in what it would suggest about the distribution of such sites. Georgian Bay's underwater landscape, like the rest of the Great Lakes system, contains thousands of square kilometers of formerly exposed terrain. If one enclosed stone structure has been found in a small area, surveyed by a researcher who was not specifically looking for prehistoric sites, the implication is that more such sites exist elsewhere, in areas that have not been surveyed or in areas where the sonar data has been collected but not examined with sufficient attention to pick out anomalies of this kind. The signal-to-noise ratio in Georgian Bay sonar data is challenging, but it is not insurmountable. With the right analytical tools and the right research team, a systematic survey of the most promising areas of the bay's underwater terrain could in principle identify dozens of candidate sites, and a follow-up investigation of even a fraction of those candidate sites would tell us things about the early prehistoric occupation of this landscape that we cannot currently know from the terrestrial record alone. The broader research program that the Georgian Bay discovery points toward is one of the most exciting prospects in North American archaeology, not because the underwater sites will necessarily reveal spectacular artifacts or dramatic discoveries, but because they will fill in the record of a period and a way of life that is currently almost invisible. The early and middle archaic peoples of the Great Lakes region, the people who lived here during the long millennia between the retreat of the glaciers and the development of the mound-building woodland tradition, are among the most poorly understood populations in the entire history of North American archaeology. Their terrestrial sites are numerous but generally thin, reflecting the mobile nature of their lifestyle, and the organic materials that would tell us most about their daily lives have largely not survived in terrestrial contexts. The underwater sites, with their cold water preservation, may be the best and possibly the only opportunity to understand these people in the kind of detail that their cultural significance deserves. Let me take you now to a different kind of evidence entirely, one that sits at the intersection of the physical and the conceptual, the material and the cultural, because the most important mystery about the underwater structures of the Great Lakes is not what they are made of or when they were built. It is what they mean, or rather, what they meant to the people who built them. And approaching that question requires thinking about the relationship between landscape, memory, and meaning in cultures that transmitted their knowledge orally rather than in writing. Imagine being a member of a community that built structures on land that is now underwater. You built there, your parents built there, your grandparents built there, and then the water came. Not all at once, not in a single catastrophic flood, but gradually, season by season, year by year, the water level creeping upward. First, the lowest areas going under, then the middle ground, then the high spots. The structures you built going under one by one, the places where you fished and hunted and camped and gathered and performed your ceremonies going under, the graves of your ancestors going under, and you and your children after you, and their children after them, watching from the new shoreline as the world you knew disappeared underwater. What would you do with that? How would you carry it forward? You would remember it. You would tell stories about it. You would name the places that went under, and you would keep those names alive in your language even after the places themselves were no longer visible. You would tell your children what used to be where the deep water is now. You would describe the paths you walked, the springs you drank from, the hills you climbed, the places where the deer came to drink, the places where the ceremonies were held. You would encode all of this in stories and songs and ceremonies that preserved the knowledge of a landscape that was no longer accessible. And those stories would be transmitted to the next generation and to the generation after that, changing shape over the centuries as the details became more distant and the emotional resonance became more layered with subsequent history, but retaining at their core some memory, some trace of what was there and what happened and why it mattered. This is not speculation about what hypothetically might have happened. This is what actually happens in oral cultures when landscapes change dramatically. We know this from documented cases in other parts of the world where landscapes have changed within human memory, and where oral traditions have preserved information about those changes over very long periods of time. The Aboriginal Australians whose stories about coastal flooding were mentioned earlier provide the most thoroughly documented example, but they are not unique. Pacific Islander traditions preserve detailed information about underwater hazards, about places where the sea is shallow because the land was once above water, about currents that behave strangely because of submerged features that the current inhabitants have never seen, but whose effects have been observed by navigators for generations. Coastal peoples around the world have oral traditions that encode information about landscape change, about the rising and falling of the sea, about the places that went under and the things that were lost when they did. The Great Lakes' indigenous traditions are no exception, and looking at them through this lens, as potential repositories of landscape memory, rather than just as religious or cosmological narratives, changes what you notice and what you find significant. The Ojibwe stories of the underworld, the realm beneath the water where powerful beings live and where the souls of the dead sometimes go, take on a different resonance when you know that the floor of Lake Huron was once inhabited. When Ojibwe stories speak of a world beneath the water that has the character of a landscape with features and places and beings that move through it in ways analogous to how people move through the terrestrial landscape, you have to at least consider whether these stories encode some dim memory of a time when that landscape was above the surface. Not as a literal description of what the world beneath the lake looks like, but as a cultural processing of the knowledge that there was once a world there, that people lived there, that it went away, and that something of it, some presence, some significance, some connection between the living and the dead, and the places where both have existed, remains. The Ojibwe concept of Manitou, the spiritual power that inhabits specific places and things and beings, applies with particular intensity to the Great Lakes themselves and to the deep water in particular. Certain spots on the lakes are known as places of strong Manitou, places where the spirit power is concentrated and where extraordinary things are possible and where ordinary precautions may not be sufficient. Some of these places, when their locations are mapped against the bathymetry of the lake floors, correspond to areas where the underwater topography is particularly complex or where submerged features of an unusual character have been identified by survey. This correspondence is not conclusive. It could be coincidence. It could reflect the tendency for unusual landscape features to attract spiritual associations, regardless of whether there is any other specific reason for the association. But it is the kind of thing that a thoughtful researcher working at the intersection of indigenous knowledge and underwater archaeology would want to investigate more carefully, asking not whether the Manitou is literally present at these spots, but whether the spiritual significance assigned to them preserves some information about what is actually there. The practical implications of this kind of investigation are concrete. If traditional place names and associated spiritual or cosmological significance can help identify priority areas for underwater survey, that would dramatically reduce the cost and time required to locate significant archaeological sites. The Great Lakes floor is enormous. Conducting a comprehensive systematic survey of all of it, or even of all the areas that were above water during the relevant low-stand periods, is not feasible with current resources. But a targeted survey, focusing on areas identified by the combination of lake-level reconstruction and traditional knowledge as likely concentrations of early occupation, is feasible. It has been proposed. It has been partially implemented in small areas, and it has, in those small areas, tended to produce results. The triangulation of these different knowledge systems, the geological and hydrological knowledge of how the lakes changed over time, the traditional knowledge of where significant things happened and why certain places matter, and the technological capability to image what lies beneath the water, is more powerful than any one of these knowledge systems alone. One of the more intriguing intersections of traditional knowledge and physical evidence in the Great Lakes concerns a phenomenon that researchers in multiple disciplines have noticed, but that has not been comprehensively studied. Across the northern and eastern shorelines of the Great Lakes, particularly in Ontario and in the northern parts of Michigan and Wisconsin, there is a pattern of traditional gathering places that persists to the present day. Locations where indigenous peoples from multiple different communities, sometimes from communities that did not traditionally share language or political affiliation, have gathered at specific times of year for centuries and possibly much longer. These gathering places are not randomly distributed. They cluster in specific types of locations: narrows between islands, points of land that project into the lake, sheltered bays at the mouth of important rivers. The locations make sense from a practical standpoint as gathering places, combining accessibility by water from multiple directions with specific resource advantages. But some of them also correspond to locations where the lake floor shows unusual features, where the bathymetric data suggests the presence of structures or formations that have not been explained geologically. The hypothesis that these gathering places persist at locations where people have been gathering for a very long time, possibly for periods extending back before the lake rose to its current level, is not one that has been rigorously tested, but it is consistent with what we know about how gathering places function in mobile societies. A gathering place acquires significance through use. The more generations have gathered there, the more significance accretes to the location. The more people travel to reach it, and the more social and ceremonial functions it takes on beyond the original practical reasons for gathering there. If a gathering place was established on land that subsequently went underwater, the people who had used it would have reason to continue gathering at the nearest accessible point, the new shoreline location closest to where the old gathering place had been. And that new gathering place would inherit some of the significance of the old one, sustained by the stories told about what had been there before the water came. Over many generations and thousands of years, this kind of inheritance of significance would create a pattern of persistent gathering places that traces the history of landscape change without explicitly encoding it. You would not look at a traditional gathering place and immediately think it was there because of a submerged ancestral site. The connection would be encoded in the stories associated with the place. Stories about why this spot was chosen by the ancestors, about what happened here in the long past that made it significant, about what lies beneath the water that makes this spot special. These stories are not always freely shared with outsiders. They are often considered sacred or sensitive, in ways that create legitimate barriers to the kind of casual ethnographic investigation that would be needed to document them systematically. But they exist, and they are, for the communities that hold them, as important a source of information about the past as any sonar image or radiocarbon date. There is one more dimension of the Great Lakes underwater mystery that we have not yet addressed, and it is perhaps the one that is most difficult to discuss without venturing into territory where the evidence is thin and the speculation is thick. But it is territory that serious researchers have entered, carefully and with appropriate uncertainty, and it deserves to be acknowledged even in a story that is trying to stay as close to the documented evidence as possible. The question is this: is there anything in the Great Lakes region, in the underwater record, or in the oral traditions, or in any other form of evidence, that suggests the presence of people in this landscape at a time substantially earlier than the oldest currently accepted dates for human presence in the Americas? Earlier than 12,000 years ago, earlier than the standard models allow, earlier than even the most expansive pre-Clovis proposals that have been advanced in recent archaeological literature? This question has to be asked carefully, because it is a question that has been associated historically with a great deal of pseudoscience and wishful thinking, with claims that have been falsified, and with theories that have been used to support agendas having nothing to do with honest historical inquiry. The history of claims about very early human presence in the Americas is full of fraud and misinterpretation and confirmation bias. Any responsible engagement with the question has to begin with that acknowledgement. And yet, the Great Lakes themselves are old in ways that human presence in the Americas, as currently understood, does not fully account for. The copper deposits that attracted so much attention and generated such an extensive mining and trade network were not formed in the post-glacial period. They have been there, sitting in the Keweenaw geology, for approximately 1 billion years. The native copper, the pure metallic copper that you can pick up and work with your hands without any smelting, is something that anyone who was in this landscape at any point would potentially have access to. Not just the people of the old copper complex, who are documented to have used it beginning 7,000 years ago. If people were in this landscape earlier, they would have had the same copper sitting there waiting for them. And if they worked it, the material evidence of that working might be on the lake floors that are now inaccessible. The genetic evidence for the peopling of the Americas has been accumulating rapidly in recent years, and the picture it is producing is more complex than any single model predicts. The consensus view that all Native Americans descend from a single founding population that crossed from Northeast Asia via Beringia no earlier than about 20,000 years ago has been significantly challenged by findings of genetic signatures in some South American and Amazonian populations that do not match the expected founding population pattern, and that suggest a more complex, multi-wave population history. Some interpretation of this genetic data imply population structures that are very old, possibly older than the land bridge crossing, possibly reflecting maritime routes along the Pacific coast at times substantially earlier than the standard models allow. None of this definitively implies human presence in the Great Lakes region before 12,000 years ago, but it does suggest that the story of how people got to the Americas is more complicated than we thought, and that complexity has downstream implications for when people might have reached specific parts of the continent. The geological record of the Great Lakes Basin contains evidence of human activity that some researchers have argued predates the standard acceptance window and that mainstream archaeology has largely declined to engage with seriously. There are finds, made at various points over the past century, of worked stone in geological contexts that, if taken at face value, would suggest a pre-Clovis or even very much earlier human presence in the region. A mastodon skull, found in dredged material from Lake Erie in the early 20th century, showed what some observers described as evidence of human working. Worked chert flakes recovered from below the till layers at several locations around the lake margins in the 1930s and 40s were interpreted by their discoverers as evidence of a pre-glacial or very early, post-glacial human presence. These finds were dismissed by the mainstream of the time and have largely remained dismissed, not because they were definitively refuted, but because they did not fit the expected pattern and the methodological standards for evaluating them were not available. The problem with evaluating these older claims is that the chain of custody for the materials has often been broken. The original specimens are not always available for re-examination with modern techniques. The stratigraphic contexts in which they were found are often not well documented by contemporary standards. The interpretation of working on stone or bone, the question of whether marks on a material were made by human tools or by natural processes, is genuinely difficult and has been wrong in both directions many times in the history of archaeology. An early researcher might see working that is actually natural, or a later researcher dismissing an early find might fail to recognize genuine working. The standard of evidence that would be required to establish a pre-standard timeline human presence in the Great Lakes region with confidence and consensus is high, and none of the older finds meets that standard. What would be required is either a well-provenient site with clearly artificial objects in a clearly dated geological context that predates the standard model, or genetic or isotopic evidence from human remains that place people in this region at an earlier time than currently accepted. Neither of these has been established for the Great Lakes region. But the search continues, and the underwater environment, with its potential for preserving materials in contexts that are not subject to the same post-depositional mixing and disturbance as terrestrial sites, is one of the places where unexpected evidence might eventually emerge. Let's bring ourselves back to the documented, the confirmed, the things we know are real and are waiting to be understood better. The hunting lanes on the Alpena Amberley Ridge, the sonar anomalies of Lake Ontario and Lake Erie, the deep water features of Lake Superior that have been seen and not explained, the Georgian Bay polygon that sits in water that was dry land 7,000 to 9,000 years ago, the copper artifact at Drop 45, the persistent gathering places along the Ontario shore, the place names that encode landscape memory, the traditional stories of worlds beneath the water, and ancestors who lived where the deep lake now is. All of these things are real. All of them are documented in some form. And taken together, they constitute a portrait of a human past in this landscape that is far richer, far longer, and far more complex than the story that most people know. The standard history of the Great Lakes region, the one that is taught in schools and presented in museums and assumed in most public discussion of the area's past, begins effectively with the arrival of European explorers in the early 17th century. What came before is acknowledged to exist but treated as poorly understood, as sparse and simple, as archaeology rather than history, as background to the real story rather than as a story in its own right. This is wrong. It has always been wrong, and the underwater evidence makes it more obviously wrong than ever. The people who lived in and around the Great Lakes for thousands of years before European contact were not sparse or simple. They were sophisticated, knowledgeable, socially complex communities with long histories of their own, with accumulated expertise in landscape management and resource exploitation and long-distance trade and community organization that exceeded in many ways the expertise of the European societies that arrived, and within a few generations had largely displaced them. The underwater sites are important not just archaeologically, but politically and culturally, because they are evidence of the depth and complexity of that pre-contact history. They are evidence that the landscape now called Canada and the American Midwest was not empty or underutilized or waiting to be developed. It was fully inhabited, carefully managed, deeply understood by people whose descendants are still here and whose rights to this land and these waters were never ceded in any legitimate legal or moral sense, however many treaties and however many generations of dispossession have intervened. The underwater structures are not just ancient curiosities, they are testimonies. They say that people were here, building things, managing resources, living full and complex lives, for thousands of years before anyone who looks like the current governments of Canada or the United States existed on this continent. That testimony matters. It matters for what it says about the deep human connection to this landscape. It matters for what it suggests about Indigenous sovereignty and the inadequacy of frameworks that treat Indigenous peoples' relationship to the land as recent or contingent rather than ancient and fundamental. It matters for the way it reframes the story of this continent, relocating the starting point of significance from the moment of European arrival back to the moment of human arrival, which in the Great Lakes region was at least 12,000 years ago and possibly considerably earlier. And it matters for what it might teach us if we are willing to learn about how to live in this landscape in ways that are sustainable over the long run, the kind of long run that spans thousands of years rather than the few generations that is the effective time horizon of most current resource management and land use policy. There is a question that I have been building toward throughout this entire story, and I want to ask it now explicitly, because it is the question that I think sits at the heart of why the Great Lakes underwater mystery matters beyond its purely archaeological significance. The question is, what kind of knowing does this place demand? The Great Lakes are not just lakes. They are a system, an interconnected web of water and land and weather and biology that functions as a unit and that has been understood as a unit by the peoples who have lived with it for thousands of years. The Anishinaabe, the people of the Great Lakes, the Ojibwe and the Odawa and the Potawatomi and their relatives have a concept called Mino Bima Adidziwin, which is sometimes translated as the good life or the good way of living, but which is more accurately understood as a way of being in right relationship with the world you inhabit. Mino Bima Adidziwin is not an abstract ethical principle. It is a practical framework for how to live in a specific landscape in ways that sustain both the human community and the living world that sustains it. It is built from thousands of years of observation and experience and reflection on what works and what does not work in the specific conditions of the Great Lakes region. And it is, in important ways, incompatible with the frameworks that have governed the use of the Great Lakes region since European colonization, frameworks that have resulted in dramatic degradation of the lakes themselves, the loss of fisheries, the contamination of water, the disruption of the hydrological and ecological processes that make the lakes what they are. The people who built the structures on the Alpena Amberley Ridge knew the landscape they were working in a way that we do not. They had lived in it for generations. They had watched it change. They had adapted to those changes and had built knowledge systems and social systems designed to sustain their communities in this landscape over the long term. They were not perfect, and their societies were not ideal by any abstract standard, but they were successful in the most fundamental sense, which is that they sustained themselves in this landscape for thousands of years without destroying its capacity to sustain them. The descendants of those people, the Anishinaabe communities that persist around the Great Lakes today, carry forward elements of that knowledge and those frameworks even after everything that has happened to them. And the question of what role their knowledge might play in understanding and protecting the Great Lakes going forward is one of the most important practical questions raised by the entire story of underwater archaeology in this region. This may seem like a long way from sonar images and stone hunting lanes and copper artifacts on the floor of Lake Huron, but it is not. The underwater structures are not just evidence of the past. They are evidence of a relationship between people and landscape that endured for thousands of years, that was built on intimate knowledge, that was expressed in stone and in practice and in story and in ceremony. Understanding that relationship, understanding what the people who built those structures knew and how they came to know it and how they transmitted and applied that knowledge is not just a matter of historical interest. It is a matter of practical relevance for how we manage the Great Lakes watershed today and into the future. The lakes are under enormous pressure from 150 years of industrial use. Their water quality, their fish populations, their ecological integrity are all compromised in ways that are serious and in some respects accelerating. The knowledge systems that the underwater archaeology points toward, the systems that sustained this landscape for thousands of years, are relevant to the challenge of restoring and sustaining it now. None of this means that we should romanticize the past or pretend that pre-contact indigenous societies were perfectly ecologically sustainable, or that returning to the past is either possible or desirable. It means that the knowledge encoded in the long history of human inhabitation of this landscape, including the knowledge that the underwater sites represent, is a resource that has been enormously undervalued and often actively suppressed by the dominant institutions of the past several centuries. And part of what recovering and respecting that resource looks like is taking seriously the full depth of the human history of this place, including the chapters that are currently sitting on the lake floors, waiting for someone to look. The future of Great Lakes underwater archaeology depends on several things coming together in ways that have not yet happened fully. It depends on adequate funding, which in turn depends on political will and public awareness of the significance of what might be found. It depends on regulatory frameworks that are appropriate to the complexity of the jurisdictional and ethical situation, frameworks that give indigenous communities genuine control over the investigation of their ancestral heritage, rather than token consultation rights. It depends on technological development, particularly in the areas of sub-bottom profiling and low-cost ROV systems that would make comprehensive survey of large lake floor areas economically feasible. And it depends on the willingness of the academic archaeological community to treat the Great Lakes underwater record with the seriousness it deserves, to invest careers in it the way researchers have invested careers in the terrestrial archaeology of the region, to build the institutional frameworks and the research programs and the collaborative relationships that would allow this work to proceed systematically over the decades it would require. None of these things are beyond reach. They require intention and effort and time, but they do not require technological miracles or political revolutions. They require the decision, made by enough people in enough positions of relevance, that understanding what lies beneath the Great Lakes is important enough to be worth the effort. And making that decision requires knowing what might be down there. It requires knowing that this is not a speculative enterprise but an investigation of real structures built by real people who lived real lives in a real landscape that is now underwater. It requires knowing that the questions raised by the existing evidence are genuine scientific questions, not fringe speculation, and that answering them would genuinely transform our understanding of North American prehistory. It requires knowing that the potential is proportional to the size of the landscape, enormous in every sense. There is a particular light that happens on the Great Lakes at certain times of year, in late summer or early autumn, when the air is clear and the sun is low and the water is at its calmest. The surface of the lake becomes a mirror of extraordinary stillness, and for a moment, if you are out on the water in a small boat or standing at the edge of a cliff above the shore, you can see into the water rather than just seeing its surface. You can see the green-blue depth of the shallows, the rocks on the bottom, the shifting patterns of light on the sand. You can see, for a moment, what is beneath. And what you see is a glimpse of a world that exists in parallel to the one you inhabit, that follows its own rhythms and its own laws, that was present before you arrived and will be present after you are gone, that holds within it evidence of the long human history of this place in ways that the landscape above the waterline no longer does. That glimpse, that moment of seeing through the surface, is what the underwater archaeology of the Great Lakes is trying to extend and deepen. To look not just at the surface of this history but into it. To see not just the recent layers but the deep ones. To understand not just the last 500 years of this landscape's human history, the years that left written records and physical monuments and living memory, but the full 12,000 years or more of human inhabitation, the years that left their marks in stone arrangements on a lake floor and copper artifacts in cold water and hunting lanes built for animals that have not been hunted in this part of the world for thousands of years. To see all of it, or as much of it as we can recover, and to let what we see change how we understand where we are and who came before us and what they knew. The Great Lakes did not begin their story when Europeans arrived. They did not begin when the Wendat Confederacy or the Anishinaabe peoples took shape in their current forms. They did not even begin when the glaciers retreated and the first post-glacial hunters followed the caribou across the Alpena Amberley Ridge. The human relationship to this place is old in ways that we are only beginning to measure, and the evidence of that relationship, preserved in cold water at depth, is one of the most extraordinary archives of the deep human past that exists anywhere on Earth. We have barely begun to read it. What we have read is already astonishing. The structures are there. The questions they raise are real. The people who built them were real as you and I, living full lives in a landscape they understood far better than we understand it today. And the story of those people, of what they built and what they knew and what happened to them and what their descendants carry forward, is not a separate story from the story of the Great Lakes today. It is the same story, continuous and unbroken, flowing like the water itself from some source we cannot quite see, all the way to the present moment, where you and I are here together, sitting with the mystery of what lies beneath. The cold, dark water keeps its secrets well, but not forever. The sonar images accumulate. The researchers ask their careful questions. The elders share pieces of knowledge that have been kept safe for generations. The technology improves, and slowly, piece by piece, the outline of what was down there begins to emerge from the darkness, like a landscape slowly revealed by the receding of a fog. What we find when the fog clears will not be what anyone expects. The history of archaeology guarantees that. The surprises are always stranger and more significant than the predictions. Whatever lies on the floors of the Great Lakes, whatever the full extent of the human occupation of that drowned landscape turns out to be, it will be extraordinary. Because this landscape itself is extraordinary, and the people who lived in it were extraordinary, and the evidence they left behind, even the evidence we have not yet found, is evidence of something that deserves to be remembered and understood and honored. The lakes are patient, the water is cold, the structures sit in the dark and wait. And out here on the surface, in the present, in the long continuation of a story that began before history had a name, we are just beginning to ask the right questions. If these quiet hours in the deep past of the Great Lakes have given you something to hold on to as you drift towards sleep, something to carry into your dreams about the people who were here before any history was written, about the world that now sits beneath the water, about the long continuity of human life in this place, that is exactly why I make these videos. Maybe subscribe and let me know, where are you right now and what time is it? Someone is listening from the shore of one of these lakes right now. Someone is lying in a room that sits on land that was once part of the world we have been walking through tonight. The water is out there, cold and dark, holding everything, and the story is not finished. It is just beginning to be told. When this video ends, if you feel like it, leave a comment. Tell me where you are in the world tonight, what landscape is outside your window, what time the clock shows in your corner of this planet. I read every one of them, and they matter more than you know. They remind me that these stories reach into the dark in all directions, to people in places I will never visit, lying in the stillness of their own particular nights, connected for a few hours to a past that belongs to all of us. Rest well. The water will be there in the morning, and so will the mystery. There is a particular problem with how we measure time in the context of this story, and it is one worth sitting with before we close. When an archaeologist says that a site is 9,000 years old, that number is precise and scientifically meaningful, but it is also almost impossible to feel. 9,000 years is not something the human mind grasps intuitively. It is too long. It exceeds by an enormous margin the span of any individual life, of any recorded genealogy, of any institutional memory. It sits in a category of time that we acknowledge intellectually, but cannot really inhabit emotionally. And that inability to feel the depth of this time is itself a problem, because it makes it easy to treat 9,000 years as simply a long time ago, vague and undifferentiated, a period before significance began. But 9,000 years ago was not vague or undifferentiated. It was specific. It had seasons and weather patterns and individual days that were hot or cold or stormy or clear. It had children being born and elders dying and arguments between families and good hunting seasons and bad ones. It had moments of joy and moments of grief, and moments of the ordinary tedium and ordinary pleasure that make up most of any life in any era. The people who built the hunting lanes on the Alpina Amberley Ridge were not abstractions. They were individuals with names and histories and relationships and accumulated knowledge. They got up in the morning on a specific day, 9,000 years ago, and went down to the ridge to check on the lanes, and found that a stone had shifted overnight, perhaps kicked by a passing animal, and they moved it back into place. That action, the bending down and the lifting and the placing of a stone back in position was as real and as specific as anything happening right now in the present moment. The stone that was moved is still there, on the floor of Lake Huron, 40 feet underwater. This is not a mystical point. It is an empirical one. The past was as real as the present. The people in it were as fully human as we are. Their lives were as complex and as rich and as full of meaning as our own lives are. And the traces they left behind, including the traces that are now underwater, are not relics or curiosities or evidence in the abstract. They are the physical residue of a real human life, a real human community, a real human engagement with a real landscape. Understanding them as such, rather than as data points in an archaeological argument, changes how you relate to them. It changes what questions you ask. It changes what counts as a satisfying explanation and what counts as an inadequate one. The inadequate explanation for the Great Lakes underwater sites is the one that treats them as surprising but ultimately contained anomalies, as evidence of early human activity that needs to be documented and filed and then subsumed into the existing narrative of North American prehistory with minimal adjustment to that narrative. That is the institutional response that would be easiest for academic archaeology to make, and it is not a sufficient response. The sufficient response is one that takes seriously the full implications of what these sites represent. A long, complex, sophisticated human relationship to a landscape that we are only beginning to understand. A relationship that continued for thousands of years and left traces that are still recoverable, and a relationship whose living descendants are still present and still have things to say about what it means and how it should be understood and what should be done with what we find. The Chippewa and Odawa and Potawatomi elders who have engaged with the research on the Alpena Amberley Ridge and on other potential underwater sites in the Great Lakes have not, for the most part, expressed surprise at the findings. They have expressed something closer to recognition. The idea that ancestors lived on land now beneath the lake is not new to them. It is part of their understanding of their own history, encoded in traditions and stories that they have been carrying for a very long time. What the archaeological research confirms, for them, is not the existence of that ancestral presence, which they already knew, but its specific character, its material traces, the detailed evidence of what those ancestors were doing and how they were living. And that confirmation matters, because it provides a kind of documentation in the language of Western science that can be used in legal and political contexts, where traditional knowledge alone is often not accepted as evidence. This dynamic, in which underwater archaeology provides scientific confirmation of indigenous knowledge that was already held but not accepted by dominant institutions, is one of the more uncomfortable but important aspects of the Great Lakes story. It reflects a broader pattern in which indigenous knowledge about the natural and cultural history of North America has been systematically discounted, dismissed, and in many cases actively suppressed by colonial institutions, and in which scientific investigation is only now beginning to catch up to what indigenous communities have been saying for generations. The appropriate response to this pattern is not self-congratulation on the part of the scientists who are now confirming what they should have been listening to all along. It is humility about the limits of the scientific frameworks that led to the dismissal, and it is a genuine restructuring of the relationship between academic research and indigenous knowledge so that indigenous expertise is valued and utilized from the beginning of an investigation rather than only at the point where it happens to confirm what the scientists have independently found. Let's return to the water one more time, to the specific phenomenology of what the Great Lakes actually feel like to people who spend time on and near them, because this phenomenology is part of the story in a way that purely scientific description cannot capture. The Great Lakes have a presence, not in a supernatural sense, but in the way that very large, very old, very powerful physical features of the landscape have a presence. They affect weather patterns over enormous regions. They create their own microclimates, their own fog patterns, their own wind systems. They are deep enough in places to have permanent cold layers that do not mix with the warm surface water, creating temperature stratification that persists year-round. They carry ships and they swallow them. Their storms can be as violent and as deadly as ocean storms. Lake Superior alone has claimed hundreds of ships and thousands of lives over the historical record, and the historical record is very short compared to the full span of human presence on these shores. The people who lived around these lakes for thousands of years were not naive about their power. They respected it in ways that were not just practical, but deeply felt. The protocols that Anishinaabe tradition requires for travel on the Great Lakes, the offerings made before a canoe enters the water, the specific ways of speaking about the lake and addressing it and acknowledging its power, reflect a long experience of what these bodies of water can do to the people who underestimate them. And embedded in those protocols, in that accumulated wisdom about how to be in relationship with this much water and this much unpredictability, is knowledge that is genuinely relevant to everyone who lives in and travels on the Great Lakes today, indigenous and non-indigenous alike. The modern Great Lakes are managed by an elaborate infrastructure of treaties, regulatory bodies, shipping regulations, and environmental agreements that are largely products of the industrial period and that reflect the values and priorities of the industrial period. The International Joint Commission, the binational body that coordinates management of the lakes between the United States and Canada, was established in 1909, at a moment when the primary concerns about the lakes were navigation and hydroelectric power rather than ecological integrity. The frameworks that emerged from that founding moment have been modified and expanded over the decades, but they still bear the imprint of their industrial origins. The ecological knowledge that would be necessary to manage these lakes in a way that sustains their long-term integrity, the kind of knowledge that the prehistoric peoples who used this landscape for thousands of years were developing and applying, is not well represented in current management frameworks. This is not an argument for replacing scientific management with traditional practices in some simple or undifferentiated way. It is an argument for expanding the knowledge base that management decisions draw on, for taking seriously the accumulated ecological intelligence encoded in indigenous traditions and in the long archaeological record of human adaptation to this landscape, and for recognizing that the question of how to sustain the Great Lakes is not one that the industrial period has been answering well. The lakes are under enormous stress. The environmental record of the past century and a half is a record of progressive degradation, despite progressively more sophisticated management. Something about the frameworks being used is inadequate. And one source of better frameworks, one repository of knowledge about how to live with these lakes over the long term, is exactly the tradition whose deep roots the underwater archaeology is uncovering. The hunting lanes on the Alpina Amberley Ridge were sustainable. They were used for hundreds of years, possibly much longer, without depleting the caribou populations they exploited. This is not an accident or a lucky coincidence. It reflects the application of ecological knowledge over long timescales. The people who built and maintained those lanes understood something about caribou biology and caribou behavior and the relationship between hunter pressure and herd sustainability that allowed them to exploit the resource intensively, without destroying it. We do not know the specific content of that knowledge. We probably cannot recover it in full, but we know it existed because its results are visible in the archaeological record. Sustained use of the same hunting infrastructure over an extended period, no evidence of the kind of resource collapse that would accompany overexploitation. That kind of long-term sustainable use is exactly what the Great Lakes fishery has not achieved under industrial management. The populations of lake trout, whitefish, walleye, and other key species have collapsed and partially recovered and collapsed again multiple times over the past century and a half, driven by overfishing, habitat degradation, the introduction of invasive species, and the pollution of the water and the sediments. The management frameworks have improved, but they have not produced stability. The lakes that supported intensive human fishing for thousands of years are now managed by elaborate regulatory apparatus and still produce fisheries a fraction of what they once were. The people who fished these lakes for thousands of years before the industrial period were doing something differently, something better, and the question of what that something was and how its principles might inform better management today is not a trivial or merely academic question. It is in fact one of the most practically important questions raised by the entire story of Great Lakes underwater archaeology, because the underwater sites are not just evidence of what was, they are evidence of what was possible. They are evidence of a human engagement with this landscape that lasted thousands of years and sustained both the human communities involved and the ecological integrity of the landscape they depended on. That is an achievement that current management approaches have not replicated, and understanding how it was achieved, even partially and imperfectly, even through the fragmentary evidence of stone structures on a lake floor and oral traditions preserved over thousands of years of change, is worth the effort. The Great Lakes hold approximately 21% of the world's surface fresh water. In a world where fresh water is increasingly the critical resource for human and ecological well-being, these lakes are not just a regional or continental resource. They are a global one. Their long-term sustainability matters far beyond the shores of Michigan or Ontario or Wisconsin or Quebec. And the evidence that people successfully managed the ecological web of this watershed for thousands of years, the evidence that is sitting on the lake floors waiting to be found and understood, is potentially part of what we need to do a better job of managing it going forward. There is a kind of archaeology that looks at the past and sees only the past, a ruin, a curiosity, evidence of what used to be and is no longer. That kind of archaeology is valuable but limited. There is another kind of archaeology that looks at the past and sees a resource, not in the exploitative sense of a museum full of objects to display, but in the sense of a library of human solutions to human problems, a repository of experience and experiment and knowledge that was paid for in real human effort over real human time, and that deserves to be recognized as having value beyond its historical interest. The Great Lakes underwater sites are that second kind of archaeology. They are not just evidence of who was here, they are evidence of what worked. And in a world that needs to find new ways to make things work, or to rediscover old ways that have been forgotten, that evidence is precious. The water does not give up its secrets easily. The cold and the dark and the pressure of depth are formidable obstacles to understanding, but they are not insurmountable. The technology exists or can be developed. The collaborative frameworks can be built. The funding can be found if the will exists. And the will exists among the researchers who have devoted careers to this work, among the indigenous communities whose ancestors built these structures and who have their own reasons for wanting them understood and respected, among the broader public who, when they learn that there are 9,000-year-old hunting lanes on the floor of Lake Huron, respond with the kind of genuine curiosity and wonder that suggests they understand intuitively why this matters. That curiosity and wonder are themselves important. They are part of the human relationship to the past that makes archaeology possible and meaningful. The past is not dead and irrelevant. It is the foundation of the present. Understanding it better makes the present more intelligible and the future more navigable. And the Great Lakes, sitting at the center of the North American continent, holding their cold water and their preserved secrets, are one of the richest sources of deep human past that we have not yet fully explored. The work of exploring them is the work of understanding ourselves, our history, our relationship to the landscape we inhabit, and our potential for doing better than we have done. That work has barely begun. It is some of the most important work being done in North American archaeology today, and it will continue in the cold, dark water with the quiet patience of stone for as long as it takes. The structures are real. The people who built them were real. The questions they raise are real and important and deserve serious, sustained, collaborative, well-resourced investigation. And the answers, when they come, will be worth the waiting. The Great Lakes have been patient for 12,000 years. We can afford to be patient too. There is one more thread in this story that deserves to be pulled. One more dimension of the Great Lakes underwater mystery that connects the specific evidence of submerged prehistoric sites to a broader and more speculative set of questions about what we do not yet know about the deep human past of this continent. It is the thread of connection, the question of whether the peoples who inhabited the Great Lakes watershed during the long millennia of its post-glacial history were in contact with peoples elsewhere in the world in ways that have not yet been documented by archaeology. This is a charged subject. The history of claims about pre-Columbian contact between the Americas and other parts of the world is, as mentioned earlier, deeply entangled with pseudoscience and wishful thinking and ideologically motivated speculation. The most prominent versions of these claims have often been used to deny or minimize the achievements of indigenous North Americans, attributing their cultural accomplishments to visitors from more supposedly advanced civilizations elsewhere. This history makes it difficult to raise the subject at all without triggering justified skepticism. But the justified skepticism about specific bad claims should not translate into a blanket dismissal of the question itself. because the question is a legitimate empirical one, and the evidence relevant to it is still accumulating. The Great Lakes copper trade is, as I have mentioned, the most striking specific anomaly in this context. The old copper complex represents a metalworking tradition of extraordinary sophistication that appeared in the archaeological record around 7,000 years ago, with no local antecedent. The copper itself was abundant, and the working of native copper is not conceptually difficult. You hammer it and heat it and hammer it again. So the development of copper working in the Great Lakes independently is not in itself surprising. What is surprising is the scale and the duration and the sophistication of the tradition. 7,000 years ago, the old copper people were producing objects whose technical quality and formal complexity would not be matched by the earliest metalworking traditions of the Old World for several more millennia. This is not the profile of a tradition just getting started. It looks like a tradition that already knows what it is doing. Where did that knowledge come from? The standard answer is independent invention, which is an entirely plausible answer. There is no logical reason why people in different parts of the world cannot independently arrive at similar technical solutions to similar practical problems. The development of copper, working from native copper, is a fairly obvious thing to do once you are in a landscape where native copper is abundant and where you already have the stone tool technology needed to do the basic hammering. So independent invention is the null hypothesis, the explanation you stick with until evidence to the contrary forces you to look elsewhere. But it is worth noting that the evidence to the contrary, if it existed, would probably be precisely the kind of evidence that is currently sitting on the floors of the Great Lakes. The trade routes that connected the Great Lakes copper mines to distant communities passed through landscapes that are now partially submerged. The sites at which long-distance trade goods were exchanged, at which different cultural traditions intersected, at which the influence of external knowledge systems on local practices might be visible in the material record, are in many cases exactly the kinds of shoreline and near-water locations that went under when the lakes rose. In other words, if there were connections between the Great Lakes, copper tradition, and metalworking knowledge from elsewhere in the world, the evidence of those connections might be precisely the kind of evidence that is least accessible to current archaeological investigation. It might be on the lake floors, it might be in the drowned trading ports and contact zones of a prehistoric maritime world that we are only beginning to imagine. This does not mean that such connections existed. It means that the absence of currently known evidence for them is not the same as evidence of their absence. The absence of evidence is particularly uninformative in a case where the best locations for the relevant evidence to be deposited are also the least investigated locations in the entire archaeological record of the region. The question of maritime contact in the northern latitudes during the post-glacial period is one that physical geography makes easier to imagine than most people realize. The North Atlantic, in the period between 8,000 and 4,000 years ago, was a different ocean than it is today in terms of the conditions it presented to maritime travelers. The Gulf Stream was operating, keeping the waters of the northwestern Atlantic warmer than their latitude would otherwise suggest. The Labrador Current brought cold water south along the American coast, but there were seasonal windows when the crossing between Newfoundland and Greenland, and between Greenland and Iceland, and between Iceland and Norway, was manageable for people with sufficient maritime capability and sufficient motivation. The peoples who were living along the coast of Labrador and Newfoundland during this period, peoples ancestral to the later maritime archaic tradition, were genuinely sophisticated maritime people whose technology and knowledge of the North Atlantic would have made transoceanic voyages at least conceivable. Whether any such voyages occurred, and whether any exchange of knowledge resulted from them, is a question that cannot currently be answered with confidence in either direction. The genetic record does not show clear evidence of transatlantic contact in the pre-Columbian period, though the interpretation of ancient DNA evidence is complex and the coverage of relevant archaeological populations is incomplete. The archaeological record of Labrador and Newfoundland, including the dramatic Norse presence at Lansaur Meadows around 1,000 years ago, and the earlier pre-Dorset and archaic occupations that predate the Norse by thousands of years, is suggestive but not conclusive. What is clear is that the northern latitudes of North America, including the Great Lakes watershed, were not as isolated from the rest of the world during the post-glacial period as the standard narrative of pre-Columbian North America implies. They were the eastern end of a continent that was in contact, through its Pacific coast and through its Arctic zone, with populations in Northeast Asia whose maritime traditions extended across enormous distances. The specific question of whether that contact network ever extended across the Atlantic in the opposite direction is one that requires more evidence than we currently have. But it is a question that serious researchers have not abandoned. The Great Lakes themselves, sitting at the center of the continent, were not accessible to transoceanic maritime contact except through the river and lake network that connected them to the coast. But they were the terminus of the longest and most productive freshwater corridor in North America, a system of connected waterways that extended from the Atlantic coast through the St. Lawrence and the Great Lakes to the far interior of the continent. Anything that could be moved by canoe could in principle reach the Great Lakes from the Atlantic coast, and vice versa. The question of whether the Great Lakes copper found its way to the Atlantic coast and then into Atlantic maritime trade networks is one that has an answer in the terrestrial archaeological record. Yes, old copper artifacts have been found at sites along the Atlantic coast of northeastern North America, demonstrating that the trade network connecting the Keweenaw mines to the coast was real. What happened at the coastal end of that network, whether the copper was incorporated into local use patterns only or whether it entered a broader exchange system, is a question that the coastal sites can potentially address. What happened at the Great Lakes end of the network, in the drowned coastal occupation sites where the trade goods changed hands before making the long journey toward the coast, is a question that only underwater archaeology can potentially address. There is a concept in archaeology called the maritime cultural landscape, which refers to the totality of the human relationship to a body of water, including not just the sites on the water's shores but the water itself, the routes that cross it, the resources that come from it, the cosmological significance attributed to it, and the social relationships maintained across it. The Great Lakes, in this framework, are not 5 separate lakes with separate histories. They are a single maritime cultural landscape, a unified system of water that has been navigated and fished and traded across and incorporated into the spiritual geography of multiple cultures for thousands of years. Understanding that landscape in its full complexity requires looking at all of it, including the portions that are now beneath the water surface. The underwater archaeology of the Great Lakes is not a supplement to the terrestrial archaeology of the region. It is half of the story, the half that has been missing, the half that is needed to make the picture whole. When John O'Shea and his team at the University of Michigan published their initial findings about the Alpena Amberley Ridge structures in 2009, they framed their discovery carefully, with the appropriate scientific hedging and the appropriate acknowledgement of what remained uncertain. But they also said something that deserves to be quoted, not literally because of copyright considerations, but in its essence, that the potential for underwater archaeological sites in the Great Lakes was vastly greater than previously appreciated, that the methods for investigating them were available, that the time had come for a systematic effort to understand what lay beneath these waters, and that such an effort would transform our understanding of North American prehistory. More than 15 years later, that systematic effort has still not happened at the scale that the evidence demands. The transformation of our understanding that O'Shea predicted remains potential rather than actual, because the resources and the institutional will have not been assembled to make it real. This is not a permanent condition. Science moves, sometimes slowly and sometimes with sudden jumps. The development of cheaper and more capable underwater survey technology, the growing strength and sophistication of collaborative frameworks between academic researchers and indigenous communities, the increasing public awareness of what lies beneath these lakes, the accumulating weight of specific discoveries that demonstrate the potential for major findings, all of these things are pushing in the same direction. The question is not whether the systematic investigation of Great Lakes underwater archaeology will happen. It is when and under what frameworks, and who will have the opportunity to shape what it finds and what is done with it. The most important finding, when it comes, may not be the most spectacular one. It may not be the discovery of a complete prehistoric village perfectly preserved on a lake floor, though that discovery would be extraordinary. It may be something subtler, a pattern in the distribution of sites that reveals how the landscape was organized, a specific artifact whose material composition reveals trade connections that were not previously known, a sediment core that preserves organic materials from a 9,000-year-old occupation surface in enough detail to reconstruct what plants people were eating and how the local ecology compared to its modern condition. A piece of worked wood from a structure that was dismantled before the water rose, preserved in the anaerobic sediment of a lake basin. Any of these things, and 100 other possibilities that we cannot currently predict, could be the specific discovery that shifts the field, that makes it impossible to continue treating the underwater record of the Great Lakes as a secondary concern. And when that discovery comes, the story it will be part of, the story of who was here and what they knew and how they lived and what they built on land that is now beneath the water, will be one of the most important stories North America has to tell about itself. Not because it is more important than the stories told by the existing archaeological record, but because it fills in a gap that has made the existing record incomplete and in some ways misleading. Because it gives depth to a history that has been presented as beginning only recently, when in fact it goes back much further and runs much deeper. Because it makes visible the full continuity of the human relationship to this landscape, a continuity that was never broken, that extends from the first post-glacial hunters following caribou across the Alpena Amberley Ridge, all the way to the Anishinaabe elders who are currently engaged in legal battles to protect the Great Lakes from industrial pollution, a continuity that the water has been preserving in its cold, dark depths, waiting for the moment when we are ready to look. We are approaching that moment. The technology is ready. The scholarship is maturing. The relationships between research institutions and indigenous communities, while still imperfect and still developing, are better than they have ever been. The public interest is there, as the sustained attention to Great Lakes environmental issues over the past several decades demonstrates. The missing ingredient is not knowledge, or technology, or even resources, though resources are always necessary. The missing ingredient is the decision that this matters enough to prioritize, that the deep human history of one of the most important freshwater systems on Earth deserves the sustained, serious, collaborative investigation that would allow us to understand it properly. That decision, like most important decisions about how we invest in understanding the past, has to be made collectively. It has to be made by universities and funding agencies, and government bodies and indigenous nations and the public, who ultimately supports all of these institutions and who has a stake in whether the history of the landscape they inhabit is understood and honored. It has to be made by people who recognize that understanding the deep past is not a luxury or an academic indulgence, but a practical necessity for making better decisions about the present and the future. And it has to be made soon enough that the window of opportunity has not closed, that the sites which are potentially recoverable remain recoverable, that the knowledge which is potentially available to us has not been lost to time or circumstance before we find the will to seek it. The Great Lakes are still there. The water is still cold. The structures are still on the floor, in the dark, under the pressure of 40 or 100 or 300 feet of fresh water, where they have been for 9,000 years. They have waited this long. They will wait a little longer. But the time to look is now. The time to ask the questions seriously and fund the investigation properly and build the collaborative frameworks that will allow the answers to emerge and be shared in ways that honor all of the communities whose heritage is at stake. Not some vague future date. It is now, in this generation, with the tools and the knowledge and the relationships that exist right now. Because the next generation of Great Lakes underwater archaeology, if it receives the support and the structure it needs, will produce discoveries that change the story, discoveries that fill in the missing chapters, discoveries that make the human history of this place visible in its full depth and full complexity for the first time. And those discoveries, when they come, will be worth the wait. The cold water holds everything, the structures are patient, and the story of the people who built them, the story of who was here before the lakes were lakes, the story of the world that now lies beneath the surface of the world we know, is one of the greatest untold stories of this continent. It is waiting to be told. It deserves to be told. And the people who will tell it, the researchers and the knowledge holders and the divers and the sonar operators and the elders and the analysts who will together piece together what lies beneath the Great Lakes, are already at work. The mystery is real. The evidence is there. The questions are the right ones. And somewhere, 40 feet down in the cold, clear water of Lake Huron, on a ridge of stone that was once dry land and caribou country, and the place where a community built its hunting infrastructure and left behind a piece of copper from mines far to the northwest. The past is waiting, not gone, not lost, just beneath the surface, just below the water, just waiting for us to look. It is worth considering, as we come to the end of this long night's journey beneath the Great Lakes, what it feels like to stand on the shore of one of these lakes and know what you now know. The experience of the Great Lakes is different when you understand that the floor beneath the water is not simply geological substrate, but a landscape. A place where people walked and worked and built and lived. A place whose surface the wind was already crossing when those people were there, whose cold was already a fact they managed, whose storms they already feared and respected. The lake has not changed as much as everything else has changed. The water is still cold. The wind still comes out of the northwest in autumn. The ice still forms along the shallower margins in January and breaks up in April. The storms still build suddenly over the open water and catch small vessels by surprise. The lake does not care about the passage of 9,000 years in any way that is visible to human perception. It simply continues to be what it is. But you, standing on the shore with this knowledge, are different. You are standing at the edge of not just water, but time. You are looking out over a surface beneath which the evidence of a long human history is preserved in the cold. You are at the boundary between the world that is accessible to you and the world that is not, and you know that the inaccessible world is not empty, it is full. It is full of the residue of lives that were lived in full complexity and full humanity, of decisions that were made, and structures that were built, and resources that were managed, and relationships that were maintained across this water and this land over thousands of years. You are looking at 9,000 years of accumulated human presence from the outside, from the surface, knowing that the inside of that history is right there beneath your feet, separated from you by whatever depth of cold water separates the shore from the lake bed, but present, real, recoverable. That knowledge changes the experience of the lake. It makes it richer and, in some ways, more vertiginous. The ordinary pleasure of standing by the water, which is itself a pleasure as old as our species, is deepened by awareness of the depth of the human connection to this place. People have been standing at the edge of this water, or of the water that preceded this water, for as long as human beings have been in this landscape. They watched the water rise, and they watched it stabilize, and they kept coming back to its edge, kept fishing from it, and traveling on it, and drinking from it, and incorporating it into their understanding of the world and their place in it. That continuity is real. It is encoded in the material that sits on the lake floors, and feeling it, even incompletely, even through the mediation of story and evidence rather than direct experience, is part of what it means to take the deep human history of this place seriously. The Great Lakes are not just geography. They are not just a water resource or a shipping corridor or a recreational amenity, though they are all of those things. They are the site of one of the longest continuous human relationships to a specific landscape that exists anywhere in the Western Hemisphere. That relationship is documented, partially, in the terrestrial archaeological record, and it is documented, potentially in far greater detail, in the underwater record that has barely been touched. To know this is to see the lakes differently, to see them as holding within them not just water but history, not just cold but memory, not just depth but time, and to feel, standing at their edge, the pull of that depth, the invitation of that time, the call of the mystery that lies beneath. The structures are there, the questions they raise are real. The work of answering them is the work of recovering a history that belongs not just to academic archaeology, but to all of us, and most especially to the indigenous communities whose ancestors made that history and whose descendants have never stopped being connected to it. That work deserves to be done. It deserves to be done now. And it deserves to be done in a way that honors the full complexity of what the Great Lakes represent, as a physical landscape, as an ecological system, as a cultural heritage, and as a living presence that has been shaping human lives in this part of the world for as long as human beings have been here. The water holds everything. The cold preserves it, and we are just beginning to understand what is there. Let me leave you with one final image, not a sonar return or a radiocarbon date or a policy recommendation, but a scene that is as close as imagination can bring us to the reality of what once existed in these places. Picture a clear morning in October, 9,000 years ago. The sun has just cleared the horizon to the southeast, and its light is coming low and golden across the water. Except, there is no water here. Not yet. The Alpina Amberley Ridge is still dry land, a long, narrow spine of terrain that stretches away to the horizon in both directions, bounded on either side by low ground that will eventually become the floor of Lake Huron, but for now is still exposed, still carrying vegetation, still crossed by the tracks of animals and the footpaths of people. A group of hunters has been awake since before dawn. They have been watching the northern horizon for the signs they know, the distant movement of a herd of caribou descending from the high ground, the particular quality of the autumn light that tells them the animals have started their seasonal migration south. The lane structures they have spent previous seasons building and maintaining are ready. The stones are in place, the gaps between them precisely calibrated to the width that will guide an animal without allowing it to turn and break. The hunters know where to position themselves. They have done this before. Their parents did this before them. The knowledge of how to use this ridge, how to read the animal movement, and position the hunters and time the drive is carried in their bodies and minds as fluently as the language they speak. And now they see them, a movement on the northern horizon, the familiar dark shapes of caribou beginning their crossing of the ridge. The hunters exchange glances, communicate with small gestures, take their positions. The autumn light continues to come low and golden across the land. The wind is from the northwest, carrying the hunter's scent away from the approaching herd. The ridge is still. The stones of the lane structures are still. Everything is ready. What happens next is what has always happened, what has happened in this landscape, for as long as there have been hunters and animals on this particular piece of earth, which is as long as there have been hunters and animals at all, the world does its work. Life is sustained. The community that will eat from this hunt will gather tonight around a fire, and the story of the hunt will be told, and the animals will be honored in whatever ways. This particular community honors the animals it depends on and the pens. Knowledge of how this ridge works and how to use it will be transmitted again to another generation. And then, over time, the water comes, slowly at first, then faster. The lowest ground fills. The ridge becomes an island. The island becomes a shoal. The shoal goes under. And the stones of the lane structure, which the last users left in place, because there was no reason to move them, settle into the cold water and stay there. For 9,000 years, they stay there, while civilizations rise and fall on other continents, while forests grow and burn and grow again on the land around the lake. While the lake itself rises and falls slightly with climate variation, never dropping low enough to expose the ridge again, but always covering it, always preserving what was left there on that October morning, or one like it in the last season the ridge was used. Until one morning, in the early 21st century, a remotely operated vehicle descends through the cold, clear water of Lake Huron, with its lights on and its cameras running. And on the floor of the lake, 40 feet down, in water, at a temperature just above freezing, the image resolves. Stones in a line, then another line, parallel to the first, then a curve at the end, where the lane closes. The bones of a hunt that happened before history was written, before civilization was a concept, before anyone alive today had ancestors on this continent, lying exactly where they were left, waiting exactly as patiently as stone can wait. The past is not gone, it is just beneath the surface, it is just below the water, and we are just beginning to look. The lakes have always been here, long before any border was drawn across the map of North America, long before any nation claimed the watershed as its territory, long before any ship with a flag crossed these waters, the lakes were here. And the people who knew them best, who had built their knowledge of these waters and these lakebed landscapes over thousands of years of intimate engagement, they were here too. Their descendants are still here. And the evidence of that long presence, preserved in cold water and cold stone, is still here, waiting, patient as the water is patient, cold as the deep water is cold, and real as the stone that was placed by a human hand 9,000 years ago and has not moved since. This is the story of the Great Lakes. Not the story that begins with Champlain or Brûlé or the fur trade. The real story. The one that starts when the glaciers retreated and the first hunters followed the caribou onto the exposed ridges and built the first stone lanes and killed the first caribou and went home in the autumn light to their families and their fires. That story is still being told. Its next chapter is on the lake floor, waiting for us to find it.